Good morning, everyone, and a happy new year, and I hope you all had a nice Christmas as well. So this today is going to be give you an idea of what's all about with levelling. So hopefully you'll understand the processes behind levelling, what's important, what's not, and then in this afternoon we'll probably go outside and I'll show you how to read a level. And the first thing we do is do a 2-peg test to make sure that the instrument is in the usable condition. But we'll run through, as I say, some information first. So, maybe that's what I've done. Yeah. So the main objectives are understanding what a level survey is. And you've got to manage it all and put checks in it, because otherwise if you get wrong information, you'll get material taken away from site, or you'll think you need a retaining wall and you don't, and you'll have drainage problems, you'll have no end of things. And because levelling was always left to the end of any survey, so the surveyors would place station, control station points somewhere, make sure they can see all the detail, survey all the detail by measurement or through instruments. And then the last thing they did was do the levelling. And for you guys, you would draw up your survey first, and then you go back to site and you would indicate the points that you want to level. There'll be manholes, gullies, top and bottoms of walls, grid across grass or open areas, beside trees, etc., etc. So you'd number all them up, and then you'd set up your level and you'd level them up. And lots of surveyors and survey companies used to leave it in. It was a bit rushed, and they didn't give enough a lot of importance. And the thing is that when it goes wrong, it can go wrong badly. So you need to give an idea, think about the level grid you want to cover the site, and that is your level spacings. Because if you're going to do quite a lot of design and raised areas or sunken fountains or whatever, you may want a lot more levels than is normal. Because they're normal for a 1 to 200 survey, there's normally a 10-metre interval. And a 1 to 100 survey, it'll be a 10-metre interval or 5. And if you go down to 1 to 50, you'd probably 10-metre, you would have there'd be too much space between all the levels. So you want to bring that down to 2 or 3 metres. Survey companies will, if you say to them you want a 5 or a 10-metre grid, it doesn't mean to say they're going to put a level exactly over the site at 5 metre and 10 metre. They'll put additional levels on corners of buildings, tops and bottoms of banks, gullies, manholes, thresholds, etc., etc. You're going to end up with a lot more levels than you really probably need. But if you've got areas that you think you need more levels, then you need to give that some thought. And then you need to think about datums and the accuracy, because the datum is important. I don't know if you've give me a laser pointer so that the online guys can see what we're pointing at. Right, is that the right one? They don't get the arrow on me, so bear with me a sec. We'll try and get that to work later. Right. So you've been with me with the online, like 3 people online, 2 or 3 people online. They don't see, and you can't see my mouse when it's going about. But you need to pay careful attention to the datum that's used and the accuracy. All right. Datums are important because you can relate it to an Ordnance Survey benchmark, which a cut mark shown on there, and then there's one which is across in St Mary's Church, which is not in a very good condition. And the Ordnance Survey stopped updating benchmarks probably midway through the 60s, I think it was, because the government of the day decided that they didn't want to spend public money to map the UK, and the Ordnance Survey should stand up on its own 2 feet. So it was self-generating its money through mapping and creating a digital map of the whole country. And they felt, because of the new roads, the new housing estates that were put on, Beecham in the 60s, I think it was, stopped an awful lot of the railways. So therefore the tracks were taken up. Any viaducts or any bridges over roads were probably taken down because there were bigger roads put through. And a lot of the benchmarks that are on these structures were destroyed. So the Ordnance Survey didn't want to go out to recut new benchmarks everywhere and then level them all in and then check them all. So they started pulling them off the maps, and then the whole thing went digital. They started employing navigation systems, global navigation systems using GPS, so satellites. So there is still benchmarks around, and if you're a client or you want to tie it to benchmark and you find one, you need to go to the Ordnance Survey to get value of it, and then ideally you want to check it to another one too. So that could be quite a lot of work. Failing that, you could relate your surveys to the ground level of the buildings, all right? Or a manhole or a threshold in a step or anything. That'll be an arbitrary datum. But if you employ a survey company, they will probably do it through GPS and satellites. And they'll use what's known as a geoid. And the geoid is a relation to the mean sea level at Newlyn. Because they used to have Newlyn at Liverpool, and that was stopped in 1921. The reason it stopped it was you had boats and navigation charts, and a boat from Liverpool would come out loaded up with coal or whatever, come down to London, and because the London mapping was related to Newlyn, it had different datums, right? And there weren't huge differences, even if there were only 300 or 400 mil. The draft in a boat and went into London, if the maps that were related to Liverpool might have had a difference of 300 or 400 mil. So the boat, when it came in on low water level, might have grounded. So they decided to stop using the Liverpool data, redo all the charts, the navigation mapping, and base it all in Newlyn. And then when the GPS came in, they took that Newlyn value and created a geoid around the world and said through the satellite navigation, this is what we're going to call sea level. So the benchmarks are within a few centimeters of what they used to be, all right? So if I went with a GPS unit and checked that benchmark, I would get it within 10 or 20 mil from the original value. And that was within the tolerance that the Ordnance Survey allowed the accuracy of that benchmark, because that's third order benchmark. So if you get a survey company to come in and do your work, they will probably use GPS or they will use a benchmark tied to size. If you've already done some work, preliminary work, and you've based it on the floor level, you can tell them, this is my level datum, can you please relate the survey to that? So it saves you wasting all your work. Because otherwise you would end up having to have a difference. So you would need to change all your levels to match theirs, and that could be a bit of a problem. So the survey company should take that on board. They may still try and insist you do it with GPS, but just say, no, you want to relate it to the ground level of the building. And they may have to think about it a little bit more, because they'll go and put down the survey stations put a GPS pole on it, get a height and a position, and carry on surveying. If they've got to use the floor level as building, they've probably, and to be honest, most of them wouldn't even know how to use a level, because it's not something used these days, because there's so much sophisticated kit out there that gives you a height easily or easier. So they would need to get access to the building, relate the floor level to their stations, and then can relate all the rest of the control stations to that. So it might be a bit of a pain, and you might get a bit of a backlash. But generally, everybody used to use benchmarks, and very rarely did you use an arbitrary datum. All right. But if you're doing small scale surveys or small garden surveys, then you'd want to use an arbitrary datum. Question.
So I'm intrigued. How in the old days, how did they work out a datum of sea level?
In the old days, how did they work the datum from sea level? Well, they recorded the high and low level, high and low water levels over a long period, neap tides, spring tides, and eventually got a mean. So they had a big staff or a measuring stick in the side, and they would record at high tide, record at low tide. And that went on for years. And then they arrived at a zero mark, a mean sea level.
Yeah.
And then the geoid, right? So that mean sea level is not going to be the same here as it is in Scotland, right? It is now, but it never used to be.
So the question more about how do they know on that church say that's 20 metres above sea level? How do they take from you work out that that's 20 metres above? Well,
the trigonometry pillars on the photograph, they set up instruments, very accurate instruments on them, and surveyed from hilltop to hilltop over the whole country. And like they did some in France, did not at Ireland as well. Because the days when they did the mapping, that was the way that they connected it all. So it was all done through triangulation. And then quite a lot of the trig pillars, you've got a brass back on it, which is a level point. So they used to take ages coming from Newlyn up to the first hilltop and then down up to the next hilltop. And once they got that, then you could take it in and just do these loops of levelling all round. So it took an enormous amount of work, which is why the Ordnance Survey in the 70s, when they had to go on their own, they didn't want to spend all that money and time updating these levels. So it's physically somebody coming off that mark at Newlyn with a level staff, levelling to another point, checking it back, and then continuing that on. It's an enormous amount of work. On Cambridge Cottage, if you can't get access to the floor level, there's a plinth up this side here. I don't know if you ever noticed it. And plinths were put around buildings at the damp course level point, because DPC, damp-proof course in the old days, used to be just layers of slate to stop the damp coming up and into the building. So they didn't want the water splashing up above the DPC, so they put a plinth or a concrete edging, normally a 45 or a degree slope in the top of it, but used to deflect the water from the building. But if you've not got a plinth on it, you should see a thin black line, and the mortar between the bricks on the DPC is usually twice as thick as it is normally everywhere else. So they started using tar macadam strips, then they've gone on to plastic, and I think they use a combination of things these days, but very rarely will you get slate used as a DPC. But the DPC on the threshold, right on the entrance to that door there, will be very close. It'll be within 10 mil, 50 mil from the finished floor level. So as long as you establish a datum, use that for the rest of the site, and then put another couple of points on. So if you can't get access to that, they're going to refurb it, cover it all with hoarding. You go back in a month's time, you want to do more survey work, you can't do it because you can't get access. So it's in your interest to leave some other points aligned that you can use as a temporary data. All right.
Sorry,
Yes.
I'm sort of stuck on a very basic concept. Why, if we use an arbitrary datum, like floor of building, why don't we use 0 for that? Why do we use 10? Did you explain? I'm sorry.
Yeah, right. The question was, why do we use an arbitrary datum on a floor? Why, and say 10 meters, why can't we use 0? If you use a 0, which is easy then to say this level here is 0, that one out there is 20 mil or 200 mil difference to that, which is fine. But if you've got any basements or you're doing a design job and this building's getting knocked down and been put up and they're going to put basements in it and you wanted to put 0 on it, when you go down to the basement, you've got -3 meters, -6 meters, whatever. And if they say, right, we've got a wall that's coming up and that's 500 mil off the floor level, you've got to then take away the 3.6 to add on the half a metre. It adds confusion. And I've had lots of architects in the past that would use 0 on the design for the ground floor level, which is fine when you're going up, but it's not very good when you go down. You can understand it, but contractors, when they come on it, don't understand it because they're not very good at number work. So they're not going to be doing the calculations. And it just causes so many problems. So you're better using 10 meters or 100 meters or whatever, but don't use 0. All right? If you're going to use an arbitrary floor level. Because even if the land slopes away, so it's got a big garden sloping away, you'll end up with minus levels.
Thank you very much. That's clear.
Yeah? Is that fine? Yeah?
Yeah,
Yeah.
that makes sense.
It's you could end up with a hot noodle. Right. So how do we get levels? Well, we can use. Wish I could get this little laser thing off. Try it again. That's not going to get there. So you've got the blue one is an automatic digital, automatic or a dumpy level, and it's not a dumpy level. The dumpy level is a much simpler and much earlier level, and a dumpy level is you had to adjust the split bubble every time you pointed at the start. Whether I don't say it's more accurate, but you just got to fiddle about, get the split bubble to work, take the reading, you turn it around to the next point, you've got to get the bubble split, get it lined up, take the reading, turn around again. Excuse me, where an automatic level, you either tap the side of the instrument, flick the foot screw, or press a button, and that makes a compensator move. And the compensator is a wire with a prism at the end of it. And what that does is that's free to move. And that will give you a true horizontal line when you look through the telescope. All right. And that's what you're trying to read. So when you set up a level, it doesn't matter where it is, it doesn't matter what height it is, as long as you get that horizontal side exactly horizontal. So that's the idea of a digital level. The one in the middle, on the orange tripod, is a digital level, and that uses a barcoded staff. And a barcoded staff is like what you get in your shopping in Tesco's or Sainsbury's, wherever you got to set the barcode. And this whole staff is like that. So when you're leveling, you wanted to find a difference in heights, you couldn't. You had to go back to the instrument all the time to get what was displayed in the level. And it's not easy to use. It's quite accurate, but it's not easy to use and they're quite expensive. And to be honest, we used to have one and it was a bit of a pain because you had to get special software to get it down and process it. So I would say that the one on the left, the yellow one with the staff, which again is an automatic level, is much simpler. You can see what you're doing and you understand what's going on. All right. Then you come down at the bottom on the left, you've got a rotating laser level. And the rotating laser level is set up, it's self-leveling. And once it's leveled itself, and that can be set up anywhere as well, it's not particular. You either get a red or a green light that'll spin round. It is visible at times, but not all the time. And then you put a sensor on the side of the staff, and when the laser hits that, it'll tell you that it's hitting it, so you get a straight line. If you're too high, there'll be arrows on it to tell you to put it down. If you're too low, there'll be arrows to put it up. For surveyors to use it, it's a bit of a pain because all it's doing is giving the total horizontal. You've got to slide this thing up and down the staff to try and read what the level is. So you read it, you find it where the line is, book it down, go to the next point, up and down, read it, write it down. It's not ideal. It's good for contractors where they want to level a site and get exactly the correct level all across it. because all they do is set it up right. We want it 1.5 meters down from where the instrument is. They set it on the leaded shaft 1.5 meters. They go around and tell the digger driver take off another 50 mil, take off another 100 mil. Not that long. It goes beep, 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 screw, go to the next point. And it's very fast for doing that. The one in the middle, the picture with the zip level, is an American idea. And what you have is the idea of a normal measuring type, which is this box here. And you got a cable that comes out, and the cable's filled with a liquid gas or liquid. I've not looked into it. The first time I ever come across on this was when I put together this presentation. And I thought I've never even heard of a zip level or even seen one. So I found out about it. And this is carrying case. The trouble is that in the UK with health and safety, you start pulling a cable across anywhere, it becomes a trip hazard. Which is fine in a nice, flat, open area where it's only you and the zip level. But if you're on a building site or a site with the children about, you're limited to 30, I think it's 20 or 30 meters in the casing. So you've got to establish a base station somewhere and give it a datum. And it can be called 10 meters, 100 meters, whatever. You've got to fix that down, and then you pull out this cable, and then you go with this device and sit it on the top of your walls, your manholes, your floor levels, your windowsills, your gullies, etc., etc. But you're pulling it about over obstacles all the time. And it's just, and then you want to do a change point, right? So you want to move it to another place so you can get cover further the garden. So once you've established that's your change point, you take that up, put that on there, fix it down, and that's the new level. And then you can go pull that forward and continue. I would personally go back to the start point to make sure the difference in the level that was recorded is the same. Otherwise, you'd be chasing your tail. I spoke to an American last year who came over for his graduation. And he says he's been using it for years, 17 years or something. And right, it was great. And I said, well, I'm surprised. He said, no, he says, it's wonderful. The areas where this, the weather's not great. He said, well, I said, but the UK wouldn't have it because of trip hazard, or it'll get snagged or something. Or on the building site, somebody will put a bunch of materials across your cable, plant or something. Or somebody will kick it over the base station. So it's just, and I don't know anybody that's ever used one, but I put it on there because it might be something that somebody wants to look at. The alternative to that is a really simple way of just a see-through hose pipe, fill up with water, and water will find its normal level, and you can get from A to B quite easily. But obviously you're restricted in how long the hose pipe is, and a lot of water you need to carry with you, because when you go to somewhere else, you're going to lose the water. So, but you can do it, right? So there is ways of getting levels from one place to another, and the difference is by using them. You can use features on site. So you can use a wall. So if you've got a wall that's going up, you want an idea of what the garden's doing, because you want to decide whether you put tall plants or small plants or what you're going to do with it. You can measure down the end of the wall at one end, measure up the garden and get the difference at the end, and at least on your map then you can say, at point B, you've got 1.2, I got 20 meters, and at A is half a meter, so I know that it's 0.7 of a rise between A and B. And that could be useful for you designing your plan. And you could probably do some preliminary cross sections, long sections on there. Likewise, you can do the same with a fence. You can measure the end of it, measure any differences as it moves its way up the slope. Yeah. And then another way is using just a bit of wood, straight edge, a bit of scaffolding, put a spirit level on top of it, put a peg underneath it, bang it in when it's level. From A to B, measure the peg, you know what you've got. Do another one, you can work your way down. That is obviously quite time consuming. You need a whole bunch of boards. But they actually used that when they split America from the northern states and the southern states. And I don't know if anybody has heard of the Mason-Dixon line. Well, that's what they used. So they used Mason-Dixon line and used chains to measure the distances. And they used this idea to measure up the height so that you calculate the different heights. So they were chasing a latitude, and they, excuse me, they've checked it quite recently, within the last 10, 20 years. And Mason-Dixon actually got it within a few centimetres. And they've actually got all the posts still. And because I don't know, there was a quarry in the UK where they made the stone posts that they used for the boundary markers. And considering that there was guys just sitting in the back looking at the stars and pulling a chain, which is basically two handles with a few links in the middle of it. And this time they did it, and how they achieved such accuracy is quite amazing. So you can get around it with a bit of effort. Everybody okay with all that so far? Yeah. Then you get into more modern kit. So now you're getting into global positioning, which is satellite-based. GPS, Global Positioning System, or GNS, which is Global Navigation Surveillance System. And this is the handheld bit that got there. It used to be 8 hours you would have to sit on a point to let the satellites send out its signal from 4 or 5 of them. This would analyse it. And because the Americans put in an error within it all, they had software to take it all out. And you would end up getting a fix probably within 20, 30 minutes. Nowadays, though, and again, I looked at these probably 30 years ago or more, I did a survey using a normal theodolite, which gave me a very accurate angle, very accurate distance to 1 millimetre and 1 second of arc. Placed all these points in the survey, surveyed them all, and got a good closure of my Travis. Guy came along to sell me a GPS unit, and I was amazed that the level and position was only within a few millimetres. And I couldn't believe from a whole bunch of bits of metal in the sky that you could get something down to that accurate. It's quite amazing. However, people are led into a false sense of security. And at another site near Bracknell, 350 acres, where the chap who I was working for, who was one of the head of the engineering at Charles Church, who became Persimmon. Before that, there were Visa homes. So they were building, I don't know, 5, 6, 7,000 houses on this site. And the contractor to do the drainage and the roads gave them a price to do the work. And John accepted that. When they came to set it all out, they used GPS. And because they didn't do any checks on it, the GPS had errors no matter where of it. And you had drainage that instead of going that way, were going that way or flat. And when you get drainage and you build roads and tall it, houses and all that, and it doesn't work, it's a huge, smelly, hairy. So he was miffed because he actually got, I don't know if he got us in to do it, I can't remember off the top of my head. We did quite a lot of work out there for years and years and years. But what he managed to catch stuff, and then he found out that we're using GPS, and he said to me, what can I put in my tender document, David, that allows me to have confidence when a contractor comes in to do the work? I said, well, all you can do, John, is let them do the GPS fixes, because if they build that into the price, and it's a more efficient way of doing it. And they've now got them on the machines to scrape things. They use GPS. They use GPS for putting boreholes in. They use GPS for putting piles in. In the depths, they know exactly where the machine is, and it's getting quite clever.
Sorry, I couldn't catch. What do they use to do the checks then in the tender?
I'm just going to say it. So I'm going to that yet. So they were using GPS. I said to John, all you can say to them is every now and again, or at certain lengths, they've got to use conventional instruments or levels to check that out and publish that information to you. And he says, thanks very much. I never heard any more about it. So obviously the guy said, you can do that, but you're going to have to spend a load of money to get another again who understands surveying to check all the features there. But I've been back doing what they call adoption surveys on drainage, mainly. Because the sites, and I think there's some in the news recently as well, where the sites have been built. I think it's more the roads. Anyway, the council's got to adopt the drainage on the new development and adopt the roads. And until that happens, the contractor, the house builder, is liable for it all, right? So they've got an open field, They build a load of houses, they build a load of roads, load of drainage, and it's the contractor does that, and it's got to tie into existing drainage. The council will adopt that once it's been happy with the results that they get, that the drainage actually works, it goes uphill and downhill and what have you. And I went to this lovely site, the other side of Reading, Woking. Beautiful houses, lovely road, nice and quiet. Obviously the M4 was you could hear a drone in the motorway. But the stink along this road was horrible. And what it was the contractor laid all the drains, laid them flat or laid them a long way, and they were going to have to dig them all up, lower them all, come to a certain point where it used to drain by gravity normally, and build a huge big pumping station so it becomes a collector and just pump it all out. But the cost on that would have been millions. But again, it was because somebody's been surveying it and not understanding what they're doing. And that was the levels again. So the levels are a huge problem. And it doesn't become apparent. I mean, this site was probably 10 or 15 years old. And the council were going to adopt it, and then they found out that it didn't work. So they went back to the contractor. And if the contractor's still in business, you're okay. But if he's not, you're getting the situation you've got with Grenfell Tower, where they can't hold anybody liable because the companies who did the architecture or the construction of it all and used the cladding and material, they closed the companies down. So you can't take somebody to court if they're no longer there. So levels again are a problem. People now use drones to do it. You can get LiDAR cameras on drones. This has just got, I don't know, I don't think it's the LiDAR, that might be LiDAR, but that's just a general camera.
David, can I ask you a question?
Yeah.
With the excess flooding, extra water for climate, sinkholes, just talking about sinkholes,
Yeah.
there's been lost in that big sinkhole and it's still there, basically can't fix it totally. So what happens when the ground suddenly disappears? All the levels were done correctly. There's obviously that you can't hold anyone responsible because it's an act of God.
Well, they say it's, we're asking about sinkholes from Gosford. You say it's an act of God. But I heard when that happened that there was a leakage in some of the water pipes in it. And obviously there's going to be drainage coming through there. And then there's water. And if you've ever been down the seaside, you can see how the water in the sea changes things. In my mother-in-law's house, she had a broken pipe underneath that we weren't aware of. And over the years, the water took away the sand and the gravel. And again, all around Sunbury and Thames, it's all gravel anyway. And caused subsidence in the corner of the house, and you had cracks going through it. So she had the whole pathway dug up. The pipe was connected. You know, you talk a little pipe, but I don't know what size it is in Red Hill. But the thing is that if it's a substantial water pipe that's burst, which is then causing the water to go, and it will go somewhere. Water will find its own way.
Yeah.
And when it finds its own way, it's going to take whatever it wants with it. And that could be sand, gravel, or whatever. And once that's then taken away, you've got a void. And once you've got a void, anything that's above it will eventually collapse into it. So, is it an act of God? Well, again, with the building all over the UK, they've culverted lots of streams and rivers. And that's fine. But again, if they culvert some streams and rivers, and it happened down Somerset Flats,
Yeah.
if they don't take the material out, the water's got much less room to do in there. And I can remember them in the Thames in the 70s with a barge going down the Thames, taking the silt out to clean it. And I've never seen it in the last 20, 30 years. And it's the same, there was a farmer on the river down the Somerset Flats he was got to dig and taking all the silt out. And he was doing it only in his area. Because once the seawater, even though it was fresh water, I think, a lot of it, there was seawater in it, it was damaging his crops because he couldn't use them because obviously the salt is infected. So again, and then people say, no, it's for the cabbage white butterfly or whatever. It's like the parakeet things, you know, the parakeets that round the millions of them, they're devastating orchards and they're killing off a little bit of the grey squirrels, they're killing off the smaller birds because they're pinching all the food that people put out to the small native birds. So they're not spending the money to clean the rivers, so therefore the water's got nowhere to go. And if you've got culverted rivers and streams and nobody maintains that, that's going to build up. And eventually, as I say, water's going to find its own way. So if it finds its own way, you may not have had a sinkhole once upon a time, but you will do if you don't maintain it. It's a little bit, have you ever come across where water issues? So you'll get a map and it'll say on there water issues. And it's where big river starts, where the Thames starts, where the Clyde starts, where the Tyne starts. And I've seen one, and all you get is an area, so it's like a reverse of a sinkhole. You get water bubbling out the ground,
Right.
and then it forms a stream and then a river, then see. So if the force within the earth is pushing that water out for some reason, and this is what people do when they go caving.
Yeah.
All the caves are all made with water. Just over loads and loads of years. And even if the ground splits apart, water's going to get in there and carve it all out. So that sinkhole, they might say it's an act of God, so therefore your house is not insured, the road's not insured. But will they hold their hands up and say, no, it wasn't? It was the water off a broken pipe that caused it. And obviously, if there's a big hole, there's no restriction for any more flood water from the rain and all that going in there, and that's going to do damage as well. So I think it's something that, I'm amazed at just how long they're going to take to fix it. It's going to go on for years here. And people just had to get out of their houses. So they're on the blondes and they're not allowed to go in there in case that house collapses. It's terrible. But I don't think people are as honest as they need to be. And you will get, as I say, lots of companies will fold it, the directives will disappear. And I've been involved in claims against things. So I'm an expert witness brought in to try and find that information. And, you know, I've come up against brick walls within the council, trying to find out who the architects were and the consultant engineers were, and you just get closed shop. And you can't find out what the source data was. And this company was claiming for I think it was 2 pumping stations, one for stormwater and one for surface water. And the designers didn't read the survey properly, didn't do enough checks. The surveyor, for his part, and I went down obviously to resurvey it to find it was on, and I met the guy, and I'd previously met him 30 years ago. And I could see them working with the yellow jackets, and I thought, I can't go over and do my work because it's going to be a conflict of interest. So I sat in my car, had a cup of tea and a sandwich and waited for them to go. And they hung about, so I said, I've got to do my work. So I went with it. And I knew him, he said, mate, oh, you haven't seen you for years, 30 years. I said, all right, how you? He said, well, I've got a bit of an ease up here, and my son's taking over the business. He was retiring, and he's now ended up this professional indemnity claiming him. And I said, yeah, no, I've come here from the other side. Trying to fix it. He had screwed up 4 levels on a big site. And it was quite a big site. It was probably about 4 or 5 acres. Bowling and green, lots of buildings, and they converted houses and redid the building. But there was 4 levels wrong. And the reason they were wrong is he couldn't see over this fence. So he got his man to put the pole up, and it's a glass prism that you get reflections for the distance. And when they came, so they took the 4 or 5 levels. When they came to do something else, they didn't record what the changes in levels. So he put his level down, but in the machine was still high. So the stuff was lower than it should have been, right? Because you get a big high bit, got level on there, you put it down, it still thinks it's higher, so it's getting to the ground. So the cover level of this manhole was about 600 mil lower than it should have been. And the 4 levels round about it were the same. So the whole thing just served for the side. But nobody then looked at that level against that one over, and I thought, that doesn't seem right. So they had designed, knocked down loads of buildings, designed the drainage to go into this manhole, right? And it didn't work. It worked from existing because obviously the whole thing worked previously. But when they designed all the houses, they designed the houses 300 or 400 mil higher than they should have been to go into here. And it wasn't working because that made the roads were all coming out. And that's the right on, as I said, with these 4 levels, I think the professional claim was up to about £2.5 million was claimed against them. And They had done it wrong, and on his plan, he'd done a disclaimer saying, if you find anything in this survey drawing that's wrong, you need to give us a call and find it out. But when I tried to check up with the council and the architects and consultant engineer, I just got this door slammed to my face. I said, I'm trying to investigate this site to find out where the original drawings were to try and establish what was going on. And they built a new clubhouse as well for the bowling green. And I managed eventually to find out some information on the survey that was previously done. I think it was design drawings that they had the original ground levels or floor levels. And I worked back, and with a little bit of manipulation, they could have got the drains to work. But it meant we'd have to knock down all the houses and build them with 300 or 400 million. They're often almost, I think some of them were sold off land. So it was a complete nightmare. But there was a lot of people involved in this. And some engineer, a few years after, had decided that there was an error. So he had done a correction. The invert level to this manual is not this, it is this. And written it on the drawing and then published that. That was wrong. That was wrong by 300 mil. So the whole thing was, I was just pulling my hair out. And eventually, I don't know what the outcome was, but we gave us their opinion, did our reports and everything. But it was all stitch up. So the builder hadn't done his work properly and was trying to claim on everything. And yet, he should have been claiming against the designers. Because when they get the survey to do the design, they look at it all and they would have thought, hey, there's something a bit funny going on in this area. Maybe I should go to site to have a little look at it because this is where the whole site's getting drained out to. If they did it, they might have just ignored it and not understood it and thought, at the end of the day, we can claim against the surveyor because he did the original work. So, and that was levels again, and levels years down the road can come back and give you real problems. So people using drones can map something, and if you don't put down ground control, the drone is using the GPS, and we just talked about GPS for drainage over and up down. So if the satellites are not in good positions, it's not affected by weather satellites, but neither is the drone. Affected by weather, it will be affected by weather. But it depends on the constellation that it's looking at. It depends on the triangulation it gets from the signals. And if it's flying about and the wind's getting it, you could be 100, 150, 200 mil on the ground. Because when it takes the photograph, it thinks it's there, but it's not. It's actually over here. And likewise, if you're getting that 150 mil on the ground, you can end up getting 30, 40, 50 mil in high position. So where people will accept a survey from a drone, you might end up getting caught out later on if you don't find some way leveling or through to check it. And people don't want to spend the money verifying things. But then a lot of people used to use scanners when they first came out. So they would set up outside the garden and scan it. But the scanner's only going to hit what you can see. So it would hit the side of this podium, yeah? There'd be a shadow over there, so you wouldn't see it. So you'd have to set up somebody else to get that side of it. And then if it's grass and you get vegetation, it's only going to hit it where it sees the leaves. So again, people weren't putting the effort in to verify, to confirm what they've been showing. And there was lots and lots of issues with people getting cheap surveys that were no good. So this is what surveyors will use. They will use based on a zero level at Newland, but on that geoid. All right, so all this is all related to the Ordnance Survey grid system. So a professional survey should give you what you need. And if the company or who's done it should have checks built in it. If you're going to do it yourself or add to another survey, because you might employ a survey to do work, you want your client, the client pays the bill and the whole lot, and then they want to extend it a little bit. Well, the survey company come back and extend it might be the same cost as it would to do the whole survey in the first place. So you might want to take it out yourself and just extend it, because you might want to spend £300 or £400 buying a level, buying a optical square and a couple of tapes and away you go. And you would have the skills because I've taught them to you to extend it all. And if you do that, you'd want to try and put some checks and you want to sort of duplicate your work. Certainly in the initial times that you're doing it, just to prove that what you're getting is good enough. If you get cheaper than a thoughtless survey, which, that's what we've been just talking about the last 10 minutes, it may save you time. I mean, a general survey is about £800 a day. So if you're getting somebody come in and say, I'll do that for £300 or £400, it depends what you're going to do, obviously. But it may be fine, it may not be. But you can get caught out with it. And they may say, oh yeah, I could start tomorrow. Well, if a company that looks as if it's quite a large size company, or even an individual can start tomorrow, and if you say to them, no, I might not need it, tomorrow's a bit too much, can we do next week? You say, yeah, I'll do next week. He's not very busy. But if you go to a proper professional company and say, I'd like to do a survey, they say, well, we can't do anything for the next 3 weeks. So the difference in that is that somebody who can do it for 3 weeks is getting a lot of repeat business. And they're obviously out with lots of other people, and then they're doing quite good work because people get the guy who can start it pretty quickly is not got any recommendation referral. He might not be competent as you think he is. So just be careful. If he doesn't do a decent level coverage over the site, so you've got the levels and he's only putting up a level every 20 metres or something, you've got a dip in the garden, and it rains a lot and that floods out, your client's not going to be very happy. You're doing a lovely design around the borders, but you've got a big puddle in the middle that shouldn't be there. You can't use it. Yeah.
So would you adjust what you consider an appropriate level coverage according to the site? So if you see that a place is mostly flat, you do it every so often, or you will use standardized?
Right. The question was, how do we appropriate, or how do we decide the level of grid on a site that's got a big open area? If you think it's an open area and you think it's flat, the only way you can prove it's flat, put a load of levels on it. Mm. You might think it's got a dip on it, and that could be right. But you get optical illusions and things. Mm. I don't know if you ever heard the term a haw-haw, which is a boundary. That when you're sitting in the paddock, you look out, you say it's all grass everywhere. But there's a haw-haw where there's a ditch being built and a retaining wall, and it's so that animals can't get up. So when you look at it the other side, it's just a brick wall. But when you move back 20, 30 metres, it just looks like it's a little bit like infinity swimming pool. It looks like it's just straight in. So optical illusions can come on. So the only way that you can satisfy yourself what the garden is doing is put a decent level grid across it. And you're looking at 10 metres would probably be fine, but I would suggest 5 metres, maybe even 3 metres. And again, if you say to the survey company, so you're instructing them, you put together a specification and you say, I want a general 5 metre grid over the whole site. But obviously they should do extra levels down the boundaries, tops and bottoms of walls, the gullies, the manholes, tops and bottoms of banks, etc., etc. Corners of buildings. So you're going to get a lot more levels than that 5. And your level difference between it might be down to 2 or 3 metres. But they should give you no more than space than 5 metres on any level you find on the site. And that's what I would take in as an idea for level grid of 5 metres, is that no levels are further apart than 5 each, but there can be a lot more round about it.
Thank you.
All right.
I'll just answer with real life.
Yeah.
With Winter Square, small Victorian, it's a lovely garden.
Yeah.
Is your observation that in most instances a survey would be done, or it would be done regarding that scale?
This is your test site, 11 plus gardens.
Yeah.
And you're asking, would you need a survey? Is that what you're saying?
Well, yeah, I'm trying to understand at what scale, as a garden designer, you would absolutely.
When you would bring in a professional.
Yes.
Well, obviously you can get what's known as postage size gardens, which could be 3 or 4 metres wide, a couple of 3 or 4 metres long. So there's a lot happening in there. and you would hardly need to come up with a design concept, because you can either put a few pots there and a few pots there, and a bit of wooden raised planting in the middle. And I'm not being cheeky, but the thing is that you could just do a few measurements across it and get that. As for levels, again, you could use the walls and the fences.
Yeah.
So you can put a spirit level in top. Say it's that level. Yeah. What's the distance down there? What's the distance down here? What's the distance in the middle? What is the difference to the next one? Is the chain link at the back. So again, what's the difference? That hold the spirit level on the end of that. How is that related? Then go around to the other one. So eventually you've got some levels around the edge. You've measured it all. And what's happening in the middle? Well, again, you can get a bit of wood longer than your spirit level. Put that in it. There's a gap between the bottom of it, because then you've got a gate. Or is it rocking? So there's higher at the middle than this. So there's lots of things you can do without employing a surveyor. But talking about Lyndhurst Square, which is your test job, that had quite a lot of undulation, certainly at the back end, didn't it? In the southern part of the site. And then there's a sunken patio, would you call it patio, and lots of staircases. That's quite bitty. So you could do that yourself. And the way I would suggest is you could measure around the garden, around the building accurately, and then measure from the points in the main building to the fence. So you take them exactly across, on line with the garden, to where the boundary fits, and do the same at that side. And you could, if it's got a reasonable straight end, you could hook the tape along the end, go way down the end of the garden, line the building in so you know you're square with it. And again, that's going to be, you're going to be much better than that. You're only going to be like this type of distance out, because even if you go down 20, 30 metres, you can hold it, eyeball it out and say, yes, about there. If you bang on a peg or a bamboo stick or anything in that, measure to it, you've now got a zero in the corner of the building, you've got measurement to that point there. Whether it's up or down, you can work about there whether it's up or down, because then you're talking about slope distance, you need to go horizontal. Once you've established that point, you've got your baseline. You can then leave that tape on there and measure it to the sides all the way down, and you're starting to build up the survey. So you've got your house, you've measured to the front and to the side boundary. You know where this start of this side boundary is. You pull the tape right down the middle. You can measure from there to there. You can put that on the drawing, and before you know it, you've got the main skeleton, the structure of the site. Then you would say, I need to do the levelling. Now the levelling, again, after today, you'd get a feel for it. But again, the more you use that, the more comfortable you'll get with it, and the more quickly you'll get it. If there's still a risk on you getting things wrong, once you've drawn them all up, you can easily put in a few checks to make sure things are the things you didn't measure. So I didn't measure from the inside corner where the building hits the fence down to that point. And if you pull a tape through there, see how that relates to your drawing, and do the same other one. So once you get your diagonals, you're getting a solid shape. So if the line work is good, then all you're worrying about is where the heights are, where the features are, where the trees are, and things like that. And then you can use what's known as, which I taught you in November, you do trilateration. So you've got points along this baseline, this measurement on the ground. You can take it off at 10 meters and measure to something. Go down to 5 meters and measure again. You get 3 parts of a triangle. That'll fix that tree very accurately. And that's how you build it all up. And with the leveling, again, you would do the corners of the building. You would do the lower basement or the patio. And that's just a table to the wall, to the top of the wall, because you can measure the wall this side. So you can relate the wall to the bottom and do that all the way around. And you can easily get the top of the bottom of the step, which is the same as that level. And you can put your level at the top, which you come out at the top of the step, and then along the edge of the flower beds, and put a few across to get, again, if you've got features, you've got trees or bushes or anything, you can use a handheld, come out there 3 meters and put a level there. And that can go in your plan at that. So there's lots of ways you can start to build it all up. But anyway, so we're talking about a thoughtless survey. You'll certainly be where you end up with delays, because he says he can start it next week, but actually can't, because he hasn't got the wherewithal, he's sick. But it's drainage, it's the thing that catches most people out in levelling is drainage, because again, it's not thought enough about. And you can have a lovely one, or they bring in loads and loads of material. So they take out stuff, they bring stuff in, and that's got to sit, so you can vibrate it down. But you know, over a period of time, things are going to sink and compress more and more. And you might build something up to your design level, but in 5 years later, it's sunk. And then you're starting to get puddling and ponding. And I mean, your insurances, professional insurance or third-party insurance, is going to be for a period of time. And you would link that in within a year or two. If my design's all right, so somebody comes back in 5 years, 10 years down the road and says, "You did my design, and I've not got a big puddle where I shouldn't have." You know, you can say, well, it's over time, it's collapsed or it's sunk. So they shouldn't be able to put a claim over you because your insurance only lasted for a year or two. But the thing is, you should take notice of that, because in the future job, you want to make sure that you build that up. But obviously it depends on what the subsoil is like. Is it clay? Is it gravel? Is it stone, or whatever it is? But you can probably get a little bit of the idea in the geology, because of radon and things like that that are over the country, and old rubbish tips and things like that, where the government and the councils don't give it all away. Where there was an old refuge dump, because there was that child that died in a basement in Chelsea, because the other side of the M3 is now released near Thorpe Park.
Sorry.
That's right. Where they filled it with rubbish, and all that rubbish leached over under the ground, came into this child's basement and killed them. Whether it's a little bit like the sinkhole, they're not telling too much, I don't know. So nowadays they try and put barriers up around them. But the thing is, you don't know. So if you're designing it, you need to think about, and I'm sure there must be science and papers published on, if I build something, and certainly you want to do it in layers as they do with roads, you build a sub-base layer, you'll compact that down as well. Then you've got a next layer on. You're only talking about 100, 200 mil, compact that down. Then you put your grass and you put your paving slabs, or whatever you put at the top. And you know it's the best you can do to get it down. It may still sink. I don't know if you've seen lots and lots of people's driveway, but lovely driveway. You can see with the park all the time because the whole thing's sunk. So we get these dips with where the wheels are. So it's something you need to look at the ground structure, go down a reasonable depth. And I can't say because I'm not an engineer per se, but I would say that would be something we would think about. It's only going to happen once in a blue moon. But what I'm saying is you need to think about bulking, you need to think about taking materials onto site, bringing materials out, compressing it all, and the whole lot. Because that is in part and parcel of your design.
Yes, in the Victorian era, when houses were built, that's
Yeah.
Do you know the type of techniques they used, presumably in those days? Because you've probably seen it time and time again. Have you?
Well, what do they call it? I'm not sure, but if it's anything that I'm talking about with the Lindus job, I mean, I don't know when that was. It could have been 1800s. I don't know.
It was 1843, but then it was added on to up until about 1910, I believe.
Right. Well, 1910, they probably wouldn't have gone down and put mass fill concrete foundations. They will put foundation down. But what you get is like they do the Romans did. So you get a big area to spread the white, and eventually you come up with a brick structure up to where your walls are, and then you build your wall up. So that underneath the floor. I mean, you look at the Roman roads, when they dig them up, they're still there.
Mm.
So they had in the Victorian days, the Romans and all the rest of it, they weren't afraid to spend the money to get something done in their buildings. And again, they wouldn't culvert the streams and rivers, so they would leave them where the so you can't build there because the stream there, you can only build in. So they would make sure that the subsoil was good before they start. Then they spread the weight. And if you spread it over a larger area, then you get less problem with subsidence. And then they build it all up over maybe a metre, 2 meters, to where it comes into the main wall structure. And the main wall structure might have 300 or 400 mil wide, but that's spread over something that's a metre wide, so it's great. And I don't know if you've heard of concrete rafts. You have a concrete raft? Concrete raft was employed an awful lot on bungalows in the 40s, 50s and 60s. And what it is, they had ground that wasn't that solid. So what they used to do was just build a big concrete slab, 300 and 400 mil flat, and didn't put any foundations on it. Build a house on it, and the house would swim about on top of it. But anyway, that's us 11:17. Shall we have a break for a coffee and whatever?
And a biscuit.
And a biscuit, yeah.
Oh,
For
nice.
15 minutes. All right.
Thank you. Would you like us to get you something?
No, I'm fine, thank you.
David,
Yeah.
hello. I have a question, if possible.
Go on.
Thank you. It's Abby. Sorry, I'm online. I'm a little bit ill still. You talked about detail to obtain levels, and I was trying to understand it, but I don't think I understand the process. Do you think you could just talk me through that bit again?
That's doing what, sorry?
Do you think you could talk me through that bit again? The using existing detail to obtain levels. So if you have a wall or a fence, I couldn't quite get my head around the full process.
All right. Right, so that's this one, yeah?
Yes.
Yes. Right, so what you've got on here is you've got existing structures on the site.
Yeah.
So you've got a garden. The client said, do you want to do a design on this? You don't want to employ a surveyor yet. You don't want to get out and do it yourself. But you want an idea, a feel of what's going on. So what you can do is find a wall or a fence, take a distance on it, mark that down, pull that point in, and you can fix that through taping with triangulation or whatever. Measure to the end, so you get the horizontal distance, what's even on this pole, then measure the other end, so you get a difference of 0.7 to the other, yeah?
Yeah, I got the difference of 0.7. How does that tell us the levels?
Well, B, I don't know, I mean, the example doesn't show how far it is away from the house. But if you're going to base it on the house level of 0, you would find another feature to get you down to the house, or you'd use this feature, which is using spirit levels in a piece of wood. So you can say, I'm going to base it all on the ground level of my house at 10 metres.
Okay.
But what is the difference in height up to B? And it could be 200 mil, it could be, that little bit there shows it might flatten out if you don't know. I've not gone into that detail. So you would find your relationship, where you're going to base it from, find out what the difference is to B, and then you use the structure on the site to give you some difference in height as you got the ground up the garden. Yeah?
Okay. That makes more sense. I think I also need to see it in practice as well, but I think initially it makes more sense than before. So thank you.
All right, so see you in 15 minutes. All right.
Okay, thank you.
I was going to ask David.
Yeah.
Because you did the Cambridge Cottage survey, didn't you? How long did that take you?
Well, when we used to teach the students, we said, all right, this is how you do go about survey. So I was giving them tasks with types and sketches and all that. And I thought, I'll keep them happy for 5 or 10 minutes. I'll set up an instrument and I'll start observing it. But as soon as I banged in a peg in the ground and bought me tripod with the field light on it, there were all flies around me and I never get anything done. So we went back and I nipped back after we finished 3 o'clock with the ball and started surveying again. And then go out on the scanner to do it at the same time. So I was surveying it with the detail hole, con round the hole. And then set up the scanner. As soon as the scanner finished, I moved that and continued surveying. But because the sun went down, 5 o'clock, 5:30, it couldn't, because it was looking for these orbs to fix itself, it was having trouble. When I came to process it after it fell out, so I had to go back and redo a load of that. But the survey itself probably only took 5 or 6 hours to do the whole lot of that. But then they got me back in to do the other bit with the rambles at the end. So, but I mean, if you employed a survey company in to do that and say, right, we want to survey this one, levels of 5 years, we're on the detail, gullies, this round area and the bit up the back because you don't know how that ramp's going to work. And then just go outside that white wall they probably charge you a dime, so it could be anywhere between 800 and 1,000 pounds. If you've got on a scanner, because I scanned it, but I was given my elevation, so if they wanted to change it, you're looking at 2.5K for that. But that gives you a snapshot of everything.
Yeah. Okay.
Have you looked at the scan to go on the drop at all? I mean, you probably haven't at the time.
It's the beta version.
Sorry?
Which ones are the beta version?
It's you've got a PC version and a Mac version. The batch file. If you hit the batch file, if you load up scans, you can actually visit all my scans and move about and take distances. And it, certainly, if you're going to get involved with any scanners, it gives you a little bit of idea of what to do. But yeah, it wasn't bad. So I spent most of my time just talking to people.
Yeah. And the other question I was around trees and shrubs. How the hell do you get the canopy of the trees and stuff?
So it's only a generalised.
Find out.
It's a
Do you
generalised.
know what they are?
Yeah, so it's we have
actually canopy and say about it.
yeah, and we also some companies want to full widespread because obviously some trees are bigger branches on one side and another. So we'll go out at 4 up points in the axis and make vision image for the edge of the canopy. And that's the advantage you get. And I do it out to the board, so it's all simple. Yeah. Well, I do it at 1.5 up. The grounds. What's the damage there?
So we have a new game.
That was helping the chap on the last.
Yes, one late now.
It used to be you
It's fine.
you're trying to take around the tree. But if you're doing it yourself, it's different. So I said, why don't you make the diameter and just multiply the 3.14? You know, and so I was he was measuring around with me and I was doing my count. It was getting within 1.1.2. So it gives you an idea because what you want to do is you want to find out how big that tree is, in what size it is, how much water is it going to draw. Also, take huge amount of it.
But you never estimate the base of the tree.
Yes, we do.
We do.
Yeah. And what I do is you can use a clinometer, you can use an apnea level, but it is basically trigonometry. But what I do is I imagine a 4 meter so like that big pine out there, I'll just say this. Oh. And it's going to be one. But again, if somebody wants more accurate, we can laser it on it, then it's never been used, but I can actually get the laser. So if somebody's critical, again, who's involved in the field?
I think I mentioned that, I'm so big time. How did it reach like, I've been
Oh, wow.
I get angry. I love you. I said, I like this. You guys bad and it's huge and then I say. It's right there.
So they keep skating.
They were arresting people at close, like a private.
I do.
How are you?
Or like half, just got the way.
If I could.
So they shouted. It's not a car, yeah.
Yeah.
Not what thingy. Not even and it's not.
Yeah, it will be. But it's all
But I'm speaking about I have not. I have a record highly from 6 years. But I would with the rest of the ATM.
How do you real
Oh, okay.
And then those are just Just incredible.
and then she came back and was like, that was really the day we said,
Yeah.
we said,
But
you can't
you know,
look.
I would not talk about it.
And so, yeah.
Press.
Yes. Yeah.
That's just the
Yeah.
I thought that was the budget.
Are you, and if you're saying, yeah, you very creative, like,
Yeah.
and I want that.
If they leave,
You know.
like,
Well, he's blocked.
yeah, if they
No.
you know,
There's something on it.
it's only hit. And more stuff is really more exciting. So if you would.
I think it's the take something. Yeah, absolutely.
Caroline.
Well, I am. My wife works. So she has to do your.
Caroline on Wednesday.
Yeah, Tuesday.
Wow.
But no.
So it's.
So it's not like that. Wow. That's very clear. I didn't really want that.
Well, I like to say that.
Yeah.
Is she online?
No,
She's got so much left, you know.
no.
Well, then they're kind
Well,
of-
really. But I think that's a draw thing. I think it's.
I thought that-
It's appropriate, but appropriating on top of, I think something gets done. Yeah, I mean, she's definitely not excited. And then following.
Oh,
It's hand-drawn pen.
I think it's.
First grade, right.
Yes, I think that's.
That's really clever, though, using first grade to the watches.
Yeah, watch it.
they do it all over the neighborhood. Yeah.
And also that one thing, I got to
If I sit really down, because they also do.
Yeah.
Yeah.
So also,
there was something in there
now.
Carry that one.
Wasn't that it's just my videos? Yeah, so anyway. So tomorrow. Just yeah.
Well, not there, on the ground, that's good, but that was very.
Right.
Yeah. See, I didn't do any of
Yeah.
It's just, pick my group.
Yeah. Yeah.
But one
So
of
we
the.
can have these for me, but it's like the description.
Yeah.
So, yes. I think it'll be in the-
And then it's this.
Yeah, because that's like.
I don't. Like, oh,
I think I'll just wait. Like, in like. Yeah. Saw a video of the fellow jumping.
Yeah.
Yes.
That's exactly what
I
I.
would, I don't know, you guys just run it.
Yeah, there's this thing. It's not.
Oh, so, yeah. So I can do it.
Yeah.
Really. It's just that
Yes, I-
I need to make marks and that, like, that works. But
It's, yeah.
Yeah, they just take the words from right to doing it.
I think
They, I don't know if you can, that's so.
Yeah, whether it's actually from
I like to call it.
Really nice.
It's quite a strong, like, size with that.
That's
Yeah. One thing was you can see that in like this. Yeah, at the end of the day.
Yeah.
I know you yeah, you're learning something. It's like I now know. Seems to be impressed. Yeah. I don't think it's yet, because I should do really cool.
Yeah.
I will think about it. It's not really said it like.
I think, yes,
So you can.
I'm still agreeing that you don't need really. Not even
Yeah.
Sorry, so I actually, I realized. Yeah. If you look at the garden scheme design, with it, you put it on. I want to say, that's like, that's not a mistake. It's not, it's not.
So the leveling objectives are you need to adhere to leveling principles, and these are just making sure you get you set it up correctly, the level of Watterston account. You can balance out your observations, so you're not reading stuff that's really close and then doing a change point that's miles away. When this afternoon, when we go out with the rain keeps off, we'll show you how you expose that error. If you want to, I'm doing a level check, which is known as the 2-peg test. But the main thing is trying to obtain the best closures possible. And a closure is you start somewhere with leveling and you work your way around inside and you come back to that same point. And with every change point, you get the backside and you get the foresight. So the backside's where you come from, the foresight's where you're going to. Then you add up the backsides and the foresights and it should be 0. If they're not 0, excuse me, you've made an error in the booking, you've made an error in setting the instrument up and the compensator sticking, or the staff is not truly vertical. And you'll get a wrong reading if it's the more it's out of vertical. So you want to obtain the best closures possible, and you want to check and sustain the level data. And that's what it's saying. If you use the flow level on here, and I think I've got it on there as the DPC at 5.46, and that is a height which was based on GNSS, so Global Navigation Service System, and the value used was 5. Whatever it was in station, one of these stations. I can't read it because it's off the sheet. But I used a station as a base, said that's my data, and everything else is related to that. The floor levels, the plinth level, which is going down that side, it's all being destroyed right here, and all these stations, right? Manholes. I can use anything as a level data or a benchmark or a TBN because I've heighted them all and I've covered myself by making sure taking checks of them, all right? And that would be the same check that you're doing when you go around and look in a level, all right? So, 2 styles of leveling. You get what is known as a normal level loop or circuit and a sausage or level bubbles. So normally people would use this section. So they set up initially on station A with the staff, set the instrument there, sight back to the staff at station A, take a back sight, do a bunch of leveling, gullies, manholes, whatever you want, or you can go around all the stations first. But basically you would set up, take a back sight, start leveling. You want to change to get behind the building or the other side of a bush, you would say forward sight to another change point. And the change points need to be solid and movable objects. You can what's known as a crow's foot, which is just a triangular bit of metal with a dome on it and 3 little spikes, and you put that on the ground, stamp it in with soft ground, and you can put your staff on top of it. You put it on hard ground, concrete, and all that, tarmac, but you need to make sure you don't kick it because then you lose the position. You can use also a screwdriver, just push it into the ground and put the staff on top of that. So you've done your level, you started off there back side, you've done your leveling, you're on the foresight and forward. You can then move the instrument to a new position, make sure it's exactly level with that horizontal line, and then take a back sight again, where you've come from to CP1, change point 1, do a bunch of leveling, go forward to station B. And you continue that procedure. So eventually, you get back to station A. And you add up your back sights, add up your foresights, and if they don't close, you've got a problem. And what we're talking about closures within a few mil, 5 mil, 10 mil.
I'm so sorry. I'm very slow on those things. Are very unnatural to me.
All right, okay.
I don't know what a backside is and foresight is.
You'll learn this afternoon, so just take it, read
Okay.
it all then, all right, because we'll show you.
Okay.
So on your back sight is looking back to take a reading, and then you do a whole bunch of intermediate shots, and then you take a forward read, forward foresight. So you go all the way around, add up the back sights, add up the foresights. They should close, but if they don't close, any one of these shots where you're holding the staff might not be vertical. When the instrument's here, you sight that station C, the instrument gets moved to there, you're going to take a back sight, Your staff man turns the staff, picks it up, turns it round to face you because you're in a new position. He might put it in a different point. So you're going to introduce error. So ideally, the staff man needs to swivel to face that way for that instrument and then face that way for that instrument. And that is quite a small error, but it's a source of error. As I said, it might not be vertical. So if it's not vertical, not in the same point, you're introducing error. Your instrument needs to be set exactly with that horizontal line. If you don't, flick the foot screw, tap the side of the instrument, or it hasn't got a button on the side of it to excite or move this pendulum, which the light comes through. The pendulum on the glass prism tells you when it's truly horizontal. If that gets stuck in any way, the line of sight is different because it'll hit the prism, go down, and it'll be shooting somewhere else. And again, this afternoon we'll show what can happen with that and how you can overcome it. So you get back to things and you think, oh, I've got 100 mil error. Where is that? You could divide it. So you've got 1 change point, 2, 3, 4, 5, 6 change points. So you can take the 100 mil, divide it by 6, and you end up with whatever it is, 18 mil each, right? Not good. You want, as I say, get it down to 5 or 10 mil. But you don't know where the error is, right? You've just got 100 mil error. You should do it all again. So you need to do it again. And hopefully you got a better result. But if you end up still with it screwed, you're going to be pulling your hair out. To get round that, you do this method. And this method is called sausages or level. So what we're doing is we get the same number of points, cut the extra ones. So we go from station A, back sight on to station A, forward on, do a bunch of leveling, forward on to change point 1, which is there, move the instrument, back sight on change point 1, go forward with an extra change point in the middle, change point 2, back and forward, go there, and then you're on to station B. You continue going round and you come all the way back, visiting these points again. All right? Which you didn't do in that way. If you had to visit them, you'd go in here, come in here, and come in here, and come in here, and come in here. Because we've done it this way, so we go out and we come back in and we visit every station and every change point twice. That means you're getting 4 observations on it. You get a forward observation. Sorry, you're starting off, you're getting a back observation on it. You're getting a forward observation on it. Then you get a back observation on it there and a forward observation on it there. You get 4 readings when you're going out and when you're coming back in. All right? So you got 100 mil error again. Where is it? This way, you can find out the differences between the backside and foresight, the backside and foresight. So you can find out, do they agree? Because you've got 2 passes. So you can isolate and say the backsides and the foresights all add up for that loop. All add up for that loop. That loop, we dropped 100 mil. That loop, fine. That loop, fine. So that's where your error is. So it must have been either the setup or the backside or the foresight onto the station, or when you were set up here, it was the backside or the foresight. 0, 1 of their 4 observations screwed it, right? So you could easily set up your level, backside onto that, be a bit more careful this time, forward onto that, move the instrument, forward on that, sorry, back on that, forward on that, job done. Make sure the differences agree. That's the sorting, all right? So, but if you've got a house in the way or a big pond, the way to do this, as I say, you would have to go around the inside, all right? So this can be known as fly leveling or quick leveling, but this is the proper way if you want to isolate any errors. But the more you get more comfortable and familiar with the level and you can read it, so you know how to use your instrument, you understand the back sides and the foresights, you understand about balancing it, so the distance between there and there, the instrument's generally in the middle. You understand that the staff's got to be vertical. You understand that your prism has got to move, so you compensate and work through horizontal. Once you've got rid of all that and you're confident of that, you can go back and do stuff like that because you've got more confidence, you can build it up this much quicker. All right? Because you're not doing the job twice. Yeah? Make sense?
Yeah.
It sounds like you need a team two to probably, is that right? You do-
Team of two would be ideal, yeah. You can use which we will use today as a tripod, a support, which is just this thing here. Right? So it's 3 legs, clamp on the top of it, clamp one, set it up, and that can hold it. But you're walking back and forth. But you can do it on your own. So ideally, you need to take out your daughter, your granddaughter, your mum, your gran, your dad, your uncle. Because there's a lot of things you can do on your own, but it's obviously nice if you've got somebody to help. So this would isolate any errors in your levelling, and that's the observing, the booking, and the adding up basically of each bit. This, if there's an error in the instrument, won't solve it, but it'll help you isolate what it is. And if you've got an error in your instrument, you'll have differences all the way. Because when you go forward, there'll be a difference, whatever it is, and when you come back, there'll be another difference. Because the thing's not working properly. Or the crosshairs are out, or the prism is sticking sometimes. And we had at the School of Horticulture last year, where I had, I think it was 5 or 6 levels set up for the students. I think it was 12 of them. And I got them to do the 2-peg test that we're going to do here to check the instrument. And they're all booking it, writing it down. It's just that I was looking at each of them once they were doing it, and I looked at this one, tapped the side of the instrument, flicked the foot screw, and it just, foot screw moved it up and stopped. So it wasn't going up and floating, which it should do. You know, what it should do is when you tap it on the compensator, it's on the middle, you tap it or flick the foot screw, press the button, it should go up and down, and then settle. When it settles, that's exactly what it's on. And it wasn't doing it, it was just getting stuck. So it's probably going to have to go back to the manufacturer or just get bent, you know, because again, if it goes back to the manufacturer, gets surveyed, to service, it could cost 100, 150 quid, depending what's wrong with it. You can buy a new one for a couple 100 quid, you know, so. But again, it's a good practice to look after your kit. Make sure you don't get water in the box, don't leave the box open. Just look after it, don't drop it, don't kick it about. What? So what requires levelling? Well, it's everything. Datums primarily, because that's what you're going to base everything on. You're basing your whole survey line work on something, whether it's a building, whether it's a fence line, whether it's a road, whether it's 2 pegs you put in for your baseline. That is important. So your survey is going to be based on whatever. Once you've all got your line up, then the next time you use a leveling and your diagram is where it's going to be based on for that. All right. And as I said, it's not a good idea to have it 0 because you may end up getting a problem. So do it either to an honest survey benchmark if there's 1 watt too far away, or just do it as an arbitrary level of the DPC flow level. That big manhole outside that nobody's ever going to change, centre of that or edge of that will be fine. As long as you make a note of it, chop it up, and then you transfer that level to 2 or 3 other points. So if you can't get access to that, or something does happen, you've got these other points that can use as your data. You're going to do all your boundaries and your roads. And again, if you're going for a 5-metre grid, you go along the boundaries and the roads at 5 metres and extra ones where it changes the direction on the horizontal or the vertical. It's tops and bottoms of banks, buildings, DDCs, paths, services, soft, hard areas, heights of overhead wires. That's useful because if you're bringing in established trees or anything, and you haven't looked, surveyor, or you haven't looked above you to see what it is, you cannot be go ahead snagging power and telephone lines and all
How
those
do you
things.
do that safely? Because if you go anywhere near
That's right.
power cables with
That's
metal,
right.
yeah.
So you know it's going to go up to the house eaves, don't you?
Yeah, that's okay, that's fine.
So you can count bricks, and 10 bricks are going to be 750 mil if it's 75 mil, I thought, plus a wee bit for you. Right, so you can estimate it, you put a tape up, so you can estimate it, and then you see it's going down to the pole. So it's dropping. So you might want to take a metre off that for the sag, and then put on your drawn clearance take another half a metre off and say you've got clearance 3.5 metres, 4 metres. At least you're covering yourself.
Yeah.
If it's power, yes, it's a bit more dangerous. But the same applies. There's probably a standard height for electrical poles and telephone poles that BT use, because they're going to get standard pole. And they're going to dig it into the ground that much.
Yeah.
So there's going to be so much sticking. So even if you don't know and you can't measure, you can still get an idea, and they'll say that these poles are 7 metres, 8 metres long. So you put a level at the base of it, by whichever mean, then you know it's 8 metres higher, and then take off a metre just to cover yourself. Yeah. And then you can use levels to obtain the contours, and that's what was done on the Linda Square. And because areas are flat, the contours, depending on how the triangles are formed, wiggle about and don't sometimes make sense. And again, if you've got banks come up to the bottom of the garden, you could show the contours, or you could just show banking symbols. So you've got a level at the bottom, a level at the top. You don't show the contours, you just show a wiggly line, saying this is a bank, because it should be an even slope. If the slope changes, then you probably want to contour it, but if it's an even gradient, I wouldn't. But I mean, I've looked at that, and I'm pretty sure I went back to Andrew Larch at CD Service and complained. And it was my company, and I complained. Because I said, well, you had a set that was going the wrong way, and I said, the contours aren't 3D, and there's a 1/4 metre contour in there that shouldn't be there. And he said to me, we've always done that. I said, we haven't. This is never. Every thick or accentuated or major contour is either 4th or 5th contours. And if you've got 100 mil contours, 100 mil intervals, you've got 1 metre, you get 1.1, 1.2, 1.3, 1.4, 1.5. So it's 1, 2, 3, 4. The 5th one is going to be accentuated as same as that one. If it's 1/4 metre contours, you get 1, 1/4, 1/2, 3/4, 4. So there's 4. And I said, that's history, it's always been there. And he says, no, we've always done it with an extra contour. I said, well, if you've got 100 mil contours, you would never stick in an extra 1/4 metre one. It's not wrong, but it's just unnecessary. So he had it, and it was confusing the hell out of some people, because I said, well, the 50 mil contours. And I'm trying to work out what's going on. Then I said, no, it's not 50 mil contours, 100 mil contours. So on that revision, I've stripped them out. So you haven't got the 750 and the 250 contours. They've been taken out. I've taken out the ones on the steps because they were confused and you couldn't see the edges of the steps. And why would you want to contour a step anyway? But on the drive here, I thought, I've sent it out to you all, and I wondered whether I'd got the arrow right, because there was a set of steps that was coming out the basement that was the wrong way round. And because a couple of them weren't 3D and I did it, again, I thought, are we using my version, or has Andrew Larch sent a new version to you guys? But the one that I was looking at yesterday was the original one. So I don't know if the arrow in the basement, because what it should do is the arrow should be pointing, going up.
Yeah, it is pointing up.
That's fine. And sometimes if you got space, you put UP on the bottom of the ceiling, which way it's up. But you always do it up. So if you're doing roofs or anything. And it was pointing down. So anyway. So the contours are quite helpful for you guys, but they can make a drawing look quite busy. There's lines everywhere. So if you understand contours, it's not a problem. You can get a visual idea of how the lines go, the land goes. But if you don't need them, you take them off, the drawing's much clearer. And again, you could ask the surveyor, but if he gives you a layer, which I've given you as well, so in the layers at the side, if you've got a proper PDF reader, you can switch off and on the layers. Have you got that? So it makes your drawing clearer. So if you go for a printout, you need just the stuff you're interested in. But if you're getting hard copies of the survey company, you might want to say to them, can you have just a hard copy with just the line work and the descriptive text, and then another copy with the levels and the contours. All right, so you get a nice clean copy. So if you're doing any serious work, you can do that on a cleaner type copy, you can see what's going on. And then when you want to finalise that with the levels and contours to find out the height difference and what you're doing with it, we can use the other drawing. But if you got it in a PDF, you can switch them off and on. The trouble is, if you get it in a CAD file, you haven't got the facility unless you get the CAD. I don't know if you can. Better watch sketch out. Right.
I have a quick question on roads and paths. Obviously, some of them have cameras on. Do you show the camera and the non-camera heights?
We always, when we do road cross sections, we always do back of path, top curve, bottom curve, camber, centre road, and if it's whatever it is, if it's a large one, then you show it on a couple of levels. Because we used to show on the chevrons around the middle of them with quite a big, bit. So you have back of path, top curve, bottom curve, edge of chevron, other edge of chevron. If it's high in the middle, we put an extra one in, then channel, top, bottom, top, and then back of path again. Some companies don't do that. And some companies are random. The guy was working with, he would survey all his line work, and then he comes back and later and gives levels over it all, which is a useful check to make sure, if he compares the level from his line work to the levels he's proposed on that. And that's fine. But we would just mark up the road at 10-metre intervals and then just do cross sections all the way. They're all nice in the line. You line up all the levels and it looks quite tidy. And I've seen some surveyors that just have levels everywhere, and the drawing just looks messy. So yeah, we cover the cameras, and if there isn't a camera, we'll take one in the middle, which proves that if it's got a crossfall or whatever, it's flat. Yeah. So the reality is the surveyor's sites are really flat, even when they are flat, they're not really flat. You got to think about the level grid of the interval, and the level grid and the interval is basically the same. We say level grid because that's basically what you're thinking about, is that where it's on my levels going to sit. And if you're doing a big open area, you'd want a grid of levels through that anyway. And you can do it randomly with an instrument, as we do with modern kit. And I was doing that last Thursday. Did about, must be the best part, 1,000 points. And I was walking up and down this field and I kept holding the pole, and it was 10 metres stop, but I had 12 paces stop. And my mate Stuart, who's got one leg, he was recording the shots and the code. But his handsets was like going out with a bloody heavy computer. It really was. And he says, when that's attached to the pole and he's only got one leg, he says, at the end of the day, he said, I feel completely happy. Anyway, we did it all, and then he showed me because with GPS that he fed in the coordinates, then his machine was giving it the actual point, so we actually saw what the drawing looked like. And my grid actually surprised me. It was actually quite good. It was good grid, 10-metre grid on the whole side. So that is a level grid. But the interval is you can state, I don't want it anything further away than 5 metres or 10 metres, because some people, again, they'll treat everything like a 1 to 500 survey, say we only want 20-metre levels. So when you get down to 1 to 100, if you've got a 1 to 500 survey, which is, you can fit a lot of land in that, but your accuracy is only 150 mil. So the pen width on a 1 to 500 survey represents 150 mil on the ground. So anything less than that, like a buttress, you can never draw it, so it won't be shown. So it's fine for sort of feasibility for big surveys, but not fine for you guys. You need to get it down at 100 or 150. And then you're talking about it's at 15 mil or 30 mil is your accuracy, which you can see in the line. But if you've got the 20 mil, 20-metre grid or interval for your lens, fine, and a 1 to 500 because it's not black. But when you get to 1 to 100, you might have a level here and the other level's way down there. It's no good to you because you've got all this detail to look at. Likewise, if it's a big site, you go to 5-metre coverage because you want it for your design, but you want it as an overall picture and you go to 1 to 500, the thing is going to get massive figures because you're getting all these levels all very close together, which obscures almost all your line work and your tree text and your bushes and other descriptive text. So there is a balance on what plot scale you're going to use, what is the job for, how do you want it represented, and what's your interest on where do you need your levels. And my advice would be to go overboard and ask for more levels, so the grid is less, the interval is less. Because even though you may end up with an awful lot more information that you need, if you've got your system, you can switch off, can you put off into another layer, take out stuff, so you get massive levels, so you can switch them off so it's clearer. And then when you're into this area later on, you can switch them levels back on, you get more information that you need.
David, I'm interested in that you have to actually make the calculation, or you have to actually note it down as you go. Why doesn't the machine automatically store that
And
data?
it did on Thursday. On here, we're doing it manually. So
I
when you
see.
get here in the afternoon, we'll do it manually. But the instrument we were using had it on his computer. It's just calculating one. Then he could email it back to his office. And within 2 hours, he'd ship me back the final drawing. And it looked good. So the modern instruments are very, very good, but they're 30 and 40,000 quid. And then you get 10,000 quid for your software. And then you've got to maintain that software. So it's serious. But then you've got to learn how to use it. And it's like anything. It just gets complicated. Whereas this stuff is easy. It's like riding a bike. Once I show you this today and you've used it 2 or 3 times, you shouldn't forget it. And for the sake of a few hundred quid, it can do a lot. And it helps you when you get a big site. So you few years, 5 years, 10 years down the road, you get really good at it all. You've done a few surveys yourself. You've brought in survey companies to do work as well. And that's been all right. Then you get involved in this much larger job. So you get another company in to do a larger job or one that you've used. And you look at it and you think, yeah, it's all right, but I'm not sure about that bit over there. Well, if you've got familiarity with your level, you get out a level. Within 10 minutes, quarter an hour, you've taken a whole bunch of levels, you've reduced them all, you know where they are, you can compare them to the drawing, and immediately you know the survey is good, which then means your design's going to be good. If the survey is wrong, you need to do something about it. Get back to the survey company or query what's going on. Have you made a mistake in your positioning or your leveling, or has they done it? But at least you're stopping it before any machines get on site and start digging, destroying stuff. Because once the machine goes in and scrapes it, there's no way of checking what it used to be like. It's gone. So you need to resurvey it all, enable you to redesign it because it's changed. And then that's going to cost you, the client, more money, and they may not like that. All right. But make use of your environment. So I told you about making use of the walls, the fences, the planks, spirit level, changes in height. You can do the same thing. You know what the level is there. You know the height of that. That drops down 50 mil, goes across here. Could be a slight incline in it. Top of the wall, other side. You get to that wall, get up to the height, and then you've got a confirmation of the back of path level on the other side. And that's without any instrumentation, then you just take a few heights right with it. All right? So you're making use of what you got round about. How to set up and level an instrument. I've got that. We've got handouts for you that we'll take out, read out, and then we'll use outside. So at lunchtime, you can hand them out. But basically, what you do is surveyor stands there. He's got the instrument over the top of the tri-rack, over the top of the tripod. He's got it almost level. Clamps on the instrument, tightens up finger tight. Then the bubbles, whatever it is. And you line the telescope to the 2 things, and you use both fingers at one time. And whichever direction your left hand moves, the bubble will move. So I want the bubble to move that way. So I'm going to move both hands in a bit, and the bubble will move. So I've got it there now, right? So I've moved them into there. And then I'll go around the stand there and use the left hand thumb again, and I'll move it out because the bubble is going to move from there to there. Basically, that's how you do it. So how do you read a level stuff? So I was talking about balancing a level. So your level ideally should be in the middle of change points. It doesn't need to be in the middle. You know, you can take your galleys, tops, or bottoms of walls, whatever. Don't exceed 30 or 40 meters. And you can take stuff that's quite close, but you'll find out when you're observing it quite close, which we will do this afternoon, you're only going to see a tiny wee bit of the stuff, and it's very hard to determine what you're looking at. So you need to get your staff man to move a finger up and down or do what to read it. So ideally, anything within 3 or 5 meters is about your maximum, but you can go out. And then when you do change points, you want to keep them a reasonable distance apart, even distances if you can. So this is where what you see when you look through the telescope. You've got the main crosshair, which is what's used for levels, and you've got another little one at the top there, another little one at the bottom. And these are the top and bottom stadia. And you use that for another thing to give you distances, tachymetry and so on. But where this is pointed, so you get 1.1, you get 1.5, which you know is the top of the E. So the E's are reversed when you go up the staff, and it is to make it easy so you can read it from far away. So it's 1.15. Then you've got the end of the start of the next block, which is 1.6. There's 1.16, and then you're reading the millimeters, which is halfway with this point through it. And again, you'll get used to this when you do it this afternoon. And if we were reading 3-year stadia, read the top one, it's 1.205 because it's halfway through that block. And the bottom one is 1.125, which is the bottom. So you take the bottom from the top, multiply it by 100, gives you 8 meters away. So that staff reading is 8 meters away from the instrument. And it's quite a fast way of picking up detail or doing a level grid. So there's two ways of doing a level grid. One is we can set it out with the right angle squares and poles, and then you just mark them in between it and you can level really quickly, providing you relate the corners to your survey. The alternative is you use the 3-year stadia, and there's a circle on the bottom divided into degrees, and that you can use to give you an angle. So you would have a reference on the corner of the building, zero that, take the distance to it, then go out to your level, take the distance, read the angle, put that down. And when you're back in the office, you can use a scale rule and a protractor. Relative to that, you can plot all the levels. All right, it's just a bit slower, but it means you can do it. Yeah.
I'm so sorry again. I'm thinking when I look back at this slide in 2 months' time, I'm gonna look and see top of what and middle and bottom of what.
This afternoon, once you've done it, and you're going to have that, you can refer to that
Yes.
quite quickly. Don't worry about it. So when you're reading the staff, this is just various readings. So you're 3.063, and the reason it's, it's 3 because it's there, it's 0. And how is it 6? Well, you've got 1, 2, 3, 4, 5, and that's halfway between there. So it's the 5 to there, and 6 is up there. That's 3 millimeters or 3 parts on that block. And likewise with the other ones, all right? And again, it will make sense when we do it this afternoon. Somebody many years ago came up with a half meter, because this was quite hard to read over long distances, because people couldn't determine where that was. I can read the meters, I can read the decimeters, I can't read the centimeters or the millimeters. Can you make it easier? So they come up with a half centimeter stuff. Trying to work out that against that, it's not easy. It's good for close work, but not very good for far away work. Because the dot there, you've got the one up there, whereas this is beside it. Like you've got 1.10 there. But here it's 1.10 because you can see it through the telescope. And then they've split the boxes into other bits, and they've got a little tick on the end where it's 1.05, which is the top of that, the E. So once you're very far away, you're never going to see that. And it's on interpolation again. So I've had one of these, and I thought I'd take a photograph of it just to show you, but it's never used. I haven't seen anybody use it in the last 40 years. But it is there if you need it. You can buy a half centimetre staff. Probably only 1 or 2 people that will do them, if that. You'll always get an E-style staff. All right. So how are we going to check it? And this is what's called a 2-peg test. So we'll choose 2 points out here. I've got a nail up here and a nail down there. They're about 30 metres apart. It doesn't matter. For this exercise, it's probably 28 metres apart or something. You can go to 50 metres apart, but I wouldn't go any further than that. So you get either 15-metre observations forward and back, or you've got 25 metres back. What we're trying to arrive at is there any errors in the stadia, which is the crosshairs that you see through the telescope. So we've set 2 points, read them, move it to just within a meter of this point and read them again. And then you go back to the start point and read it all again. And this instrument's got a little bubble in it, and this one hasn't. And this is the one that I've had for 40 odd years. Haven't used it at all in the last 30 years. I flick the foot screw back and forward to get the compensator to work. And yesterday we got it within a millimetre, so there's no error in it. And that's been in and out of my loft, in and out of my car. So the things you get from that is the instrument's good, I look after it, and there's no reason why it shouldn't go out of coordination or an error. So I can use that instrument and level anything and end up with confident that I'm going to get a good result from it. So if you buy a level or you rent out a level to do a few levels in a job, you want to do this exercise first to make sure it works. And then when you're happy that you do it, you can do it, then you can do your levels. And it'll help you get a feel of how easy it is to use a level and whether it would be beneficial to it. And to be honest, if you're into this seriously, so you're going to be doing it for the rest of the foreseeable future, I think buying a level and a staff and a tripod for the few £100 it would cost you would be a good investment. But you need to obviously use it to understand how it works. But it enables you to do your own work, your own surveys, because as I said, you can take lots of things quite easily, which you're going to do anyway. But if you can then add levels to that, you're getting forward to doing your own surveys. May it be only small scale stuff. And that's great, because it saves you bringing in professionals to do it. And even if you get professionals that come in to do it, and there's issues where you want additional levels, you can easily add them to it yourself. And you know they're going to be good. So it's a good investment. So basically you read backside to A, foresight to B, move the instrument, backside to B because you're only a metre away, foresight back to A, that exaggerates the error, and then you adjust it if necessary. I'll show you how to adjust it. All right. So this is the level set up, backside 1, backside 2, then foresight 2, A and B. Doesn't matter what the ground's like. You're just getting a relative thing to test this horizontal line of sight, which is what the compensator does. And this is how you book it. So you've got one line A, the backside. You move the staff forward, you read the foresight because you're going forward. So that's the foresight. Then you move the instrument, set it up, and it's a backside again, but it's a backside in the same line to the same point, B. And then you read the foresight, the staff get this moved to the original point, you read that. And when you add up the backsides and foresights, this particular one's got a 45 mil error, all right? And that's bad, right? It should only be a few mil. So what do you do about that? Well, so you get 45 mil error, you're set up close to this station B, and your other one's far away. The only one you can adjust is the last observation, because these are all history, these are all the past. We can only adjust that one. So what you got to do is reduce that by 45 mil so that it reads 1.3. You add them up, you get the same value, right? So to get it to come down 45 mil, you undo the cover, and there's little screws at the top and the bottom. You loosen one, tighten one, and you look through the stuff at the time and make sure you bring your crosshairs down to read 1.3. All right. So from the E staff, that is there. So I'm going to bring it down from, it was 1.1, 2, 3. It was 3.5, and I need to bring it down to 1.3. All right. So I've got to adjust it so that it pulls the crosshairs down. And how I do that is adjust these little screws, which again I'll show you, and you bring it down. All right. And then once you do redo the exercise, when you get to this stage again, it'll be different because you'll move the instruments. But basically you'll have, when you add up that lot and that column, you'll end up with 0 or 1 or 2 mil. And then you know your adjustment's good and your level's good and you can continue leveling. All right. Yep. And again, we'll do it. We'll show you how to book it down. And once we've done that, we'll do the 3 rest area to get distance. And you'll understand that because the guys yesterday were just reading it off. So that I don't know if any of them had any experience of reading the level stuff, but they just did it. And it was only at the very end they made a mistake and they were reading the top crosshair. Right? They were reading this little line up there, and one of them started doing that. And then I think somebody actually thought you could read something at the top of the actual optic, which is all you see. But that was it. So there's 2 minor mistakes and then being able to read dark stuff. And I was quite impressed. So I would like to hope that you guys are going to be exactly the same. And I'm sure you will be. So you've done your survey, you've checked your level. It's only line work, and now you need to put some levels on it. Where are you going to put them? Well, as I said, what you need to put them on was corners of buildings, walls, tops of boxes, banks, service covers, etc., etc. So what you do in your sketch is you would put little numbers across this where you want it and go around the site as many times as you want, putting levels. You know, you've got service cover there, manual there, probably step, a doorway there, threshold there, manual, edges of the pathway, behind the trees, build it all up. So you put lots of numbers on it, and it's a blank piece of paper. You have as many bits of paper as you want, put it on there, and you eventually cover your site with levels once you've reduced them. Once you've observed them and reduced them all, you can add them to the drawing. Because you know that point there is number 13, and that point there is 12. And this point down here is number 11, right? And that's how you do it. So you just build the whole thing up. And then you can contour it. And once you've got levels everywhere, you know where that contour bar is passing through. So that's how you do that, and that's your final result. And then how would you, so you've got a survey, you might add some levels, but you might want to check, is it any good? Well, you've got the scale bar on it, so you can check, does it measure from A to B, what can we expect? If you haven't got a scale bar, this line here is the Ordnance Survey digital data grid, and I think that was 50 metres, probably. But what we do as a survey company is we will accept that we'll put our own grid on it, and we've got 10-metre grid. So the difference between that cross there and that cross there is 10 metres, and between that point there and that point is 10 metres. All right? And you can go over your drawing and check that. Probably more likely 20 metres actually, looking at that. But anyway, it's whatever it is. And likewise, you go there. So that'll check you whether your drawing has been enlarged or shrunken by the copying process. Because even if you send a DWG or a PDF to a printing company, they'll print it for you, but they may not print it exactly. They might not occupy the full sheet. They might have a border coming in or whatever. So even though it looks as if it's all right, it could be shrunk a little bit north and south, different axes. So you'd want to check the scale bar lines between the grid if you're inheriting the survey, just to make sure it's good. All right. So that when you do your design on there, you can measure off the edge of the footpath or edge of the roadway to where your design is going to make sure it's right. All right. So that checks for the scale, and you can check the details, so you can line in things. So you can stand there, line in the corner of the wall by eye, and then produce that to where it hits the wall, make a mark on it and measure into the building, and then check the distance on this drawing. And likewise, you can produce that line through there to make sure it's all right. Or you can stand here, come out 3 metres, make a mark, come out 3 metres from there, make a mark, line that through, see where that hits the wall, you see if the distance in there works out. So there's a lot you can do without going too far. And then you can just basically look at it to see if it's got coverage. Has the hedges the correct height? You easily put a tape up on that. Is that wall got the correct height? is there a slight incline up to this corner? So you start to build up your confidence in the survey. Then you say that area there looks a bit flat. It's quite critical for what you want to do in there. So you can't easily check whether the levels are correct unless you've got a level. You can set a level up in there, site station 1, station 2, because you'll have the information on the levels. Either place a rigid grid through there, which again we'll show you this afternoon. So once you get one column, relate that to the detail, this column relate to the detail, set up your rigid grid and just number it and just go back and forward, and then you can put it on top of this drawing and see how the levels correct, see if they're good. And plus it gives you a few more levels. So then you want to check the levels against the contours, you do exactly the same. So you've got difference here between 539 to 554. So between that you've got 9 from 4 is 5, 4 from 5. There's 15 centimeters difference between that, right? So at 50 mil interval contours, there are only 3 contours that passes that, right? So you get 1 there, 2, 3, and then you get 11. So between expanding another one between there and there, so you get 3, 4 against 4, 3, 4 from 3 is 9. So it's 9 centimeters between that. How many 50 mils are in between that? Probably 1 and a bit. So this is the 535, and it's very close to that. So again, the contour will weave its way through the triangle mesh that it's formed, and it's allowed, the industry allows 25% error in its line work. And then you get the other one coming through at 5.4. So that's 3 centimeters down from that. So you can quickly get an idea of whether the contours match the levels. Question?
Sorry, did you say there's 90 mil difference between the contours and 90 mil difference between the points?
The levels, 90 mil between the levels. Yeah.
So between the contour lines is what, 50?
50 mil difference, yeah. Between
50 mil between.
Yeah. So ideally it should only be one contour. 90 mil is only 150, because I think it's only 40 mil again. And you've got 50 mil, then you get 40 mil. But as I've just said, because of the computer model this, and it allows you, that is 1 centimeter away from the 55.35, and that's 534. So that contour needs to be this side of 3.4, because 3.4 is less than 3.5, which is the contour value. But the next one is at 4 centimeters or 3 centimeters before that, because it's 5.4 it's reading through there. So even though we get 90 mil between it, yeah, there should only be one contour, 50 mil, because the next one's another 10 mil further on. Yeah. But you've got the 2 because that one's very close to that. You get the idea. Once you do it again, it makes sense. Between there and there, right? So 3, 4, and 3, 9. There's 550 mil between that, right? So there's only one of the one contour going through that. So you get 535. So it's a centimeter up from that, and 4 centimeters down from that. So that's 5 centimeters between that. So it needs to be a fifth along it. All right. So that's tracing that reasonably well. Yeah. Does that make sense? A little bit. Anyway, I used to do this by hand, and in Zambia, my boss used to have site surveys that are huge. They'd probably fill the whole of this wall. And we used to do, I personally set out over 1 kilometre with 3-year stadia tachyometry. And with a 5 metre staff, sat at the bottom here on the bottom, and the middle here was at the top. And it's twice that, so it's 10 metres times 100 longer. And then was checking, because it was a bit cheeky, you shouldn't really do that. Not in there, because all you got was shimmer. You're not thinking, yeah, that's about right. I was checking it, and you're surprised how good it was. But anyway, we used to level it all, and we used to use either tachyometry, 3-year static tachyometry, or this is when EDMs were coming out, and EDMs are infrared, shoot to a prism or something in root times. And I think we used to use infrared as well, but not infrared, all microwaves, used for microwave times. But anyway, so we ended up drilling this thing, and the levels were probably about that far apart. So it could have been 20 metres or 50 metres apart, huge big site. But we just started on tracing as quick as that in the next one. And that was amazing. I thought, well, how can you do that? But then all he was doing was reading it. You know, the difference between that is a fifth of the way along there, like that through, you know, was more than that. But it was amazing. And I got very good at it as well. So you're able to read the survey and just put the contours through it. And what you do is put ticks on it. So you put a little tick, couple of ticks between that, and then a couple of ticks between the next one and the next one. And once you're happy, then you just draw the lines between them all the way you go. But this is all computer generated. So back to the principles, what we've got to do, we've got to make sure we do lithology. We've got to make sure that we get the accuracy, and we've got to make sure we consistency throughout the whole. That's now just after 12:30. Shall we break for lunch, come back at 1:15? We've got another few slides, and then we can nip outside, yeah? All right. Thank you. All right, Abby, we're just going to have a break for lunch now.
Okay, great.
So we'll see you 1:15 or thereabouts, yeah?
Okie dokie. David, a quick question.
Go on.
The paperwork that you have there, do you know if it's uploaded at all? I haven't checked, but
Yes. That's cute about it yesterday. Yeah.
okay.
So yeah, it's right up. I'm not sure the title is, but it's got a picture of a level in front of it.
Okay, I'll have a look. Thank you.
All right. Cheers. And then you'll see the video. Right. All right, so that's what I was explaining a bit extra before lunch about how to draw contours by hand. So if you want an extra contour, the site you inherited with the surveyor has got contours at 100 mil, quarter metre, half metre, whatever it is. And you want more contours because it's going to help you decide and get levels on your cross sections and your long section. You can't actually just do it by hand. Then you can look at the levels, get the distance between it, take one level from the other level, divide 8 centimetres, divide it by 5 centimetres, gives you a factor. And then what you want to say is, let's say I want a 1.5 contour to come through, so 11.15. So I've got 5 centimetres, I've got 8 centimetres different. I want to go up to 11.15. I need 3 centimetres to come up to that level. We said it was 8 centimetres between the different levels. So I want to go up 3 centimetres, which is nearly half. Yeah, 3 as opposed to 8. If it was 4, it would be exactly half. So it's nearly half. That is 2.5 centimetres between, so it's 5 centimetres. So come up 2.5 centimetres, just below it is where that 11.15 contour is going to trace through. So I put a little mark in there. Look at these two, there's 12 centimetres between that. I know I want the 1.5 again, 12 centimetres. It needs to come up 3, so it's a quarter, yeah? So I go a quarter of the line, that's half there, so it's going from there just to there. So I've got that bit of the line. And then it's going to go through this part. So from 07 to 24 is 13 or 14. No, sorry about it. Yeah, 14 centimetres. 7 from 4, 17. Yeah. So I want to go up 17 centimetres. So it's the contour that I want is 11.15. So I need to come up another 7 centimetres, halfway, or just about. Like another one there. So I've got a point there, a quarter, point there, just under that. And I've drawn an extra contour at 11.15. All right. Yeah. Question.
How would that work if the elevation descends?
It's the same way. It doesn't matter whether it's going up or down. You're just deciding you want an extra contour when you're looking at the levels to decide where that's going. That 11.15 contour is just above there, just above there, just above there. It's not going to be anywhere over here. It's only occupations through that line between 11.25 and 11. All right, so you've got what I'm saying is you might have a survey that's got 100 mil contours, quarter metre contours, a half metre contours. This one's quarter metre, yeah? So you get 11, quarter, half, 3/4, and the whole. But that's not good enough. So I want to know what the difference is between here. So I can introduce 11.15 and I can produce an 11.3, maybe 5 centimeters up to 11.4. You do whatever you want. Yeah, and it's just measuring between the levels and taking the difference, divide the difference into the distance, which gives you a factor, and then you can work out what the difference is coming up to. Or you can do it by eye. You know, whether it's a third, a fifth, a quarter, a halfway, or whatever. And it doesn't matter really, you know, if you put the contour there, we said there was 17 between that. So we wanted to come up 8. So it's nearly halfway. So it doesn't really matter if you, that'd be wrong if you're right near these, but if you're almost in the halfway mark, it's fine. Because it's an estimation and it's giving you a guide. And when you pull the contour, your cross section through there, you're going to hit that one. So it's going to go here. You hit that one, you know it's 11 meters. The next point in the cross section is where you've drawn that line through here. So that's going to be 11.15. The next one's 11.25. Then you might actually come across near to 11, use 11.42. You end up going your cross section. So you can, don't get scared of it, just work it out. And as I say on that site that we've got at Lyndhurst Square, it's a flat area where the contours are wiggling about. So you can look at the levels in there and add a couple of contours of whatever division you want. And it may help you, as I say, when you're building a cross section for long section. But that's the mechanics of it. And again, there's text in there to explain exactly how to do it. And there's 2 or 3 other methods you can do it. You can do it what's called a fan method, where you put, this is better for this tracing paper, you put a fan through it and you match it on to where you want the levels to come through. And you might only be 1, 2, or 10 contours go through, and you put the fan on, you can easily take it all off. I've used it 50, 60 years ago, and it was all right, but it's a bit this is much easier. Use a scale rule and just a calculator, take one from under, draw the line. And then you'll get the stage if you used to it, and you'll be able to eyeball. You know the difference between that is almost parallel. So if I wanted to put one through the middle of that, it'd be quite easy to trace it. All right. It only gets difficult when it's on flat ground where the contours are snaking around. But it's something, don't be afraid of it. So what do they look like? Well, this is it. So you've got the representation going up the hill against the contour values. And where you got a cliff, the contours are really close together. If there was any more than that, they would probably put cliff symbols on it. So you'd miss out the majority of the thick the contour all back together. And if that was a bank, then you could get banking symbols coming down. And there's it just with slices through to help you understand. Because some people can't understand contours. And I had one student, quite a few years ago now, used to cut up bits of paper in the shape of the contours and put them on a survey plan to get an idea of actually how they went, and then decide which you're going to put a flat areas or raised areas, and just got a brain around it. And then once you understood it, it was fine. You could visualize what is going on. Is it steep, they're close together, or is it pretty easy where they're further apart? And I think they use that in the telly all the time with their isobars when they're coming through from weather. Packed together, very windy, far apart, it's not so windy. Yeah?
Yeah.
Somebody was asking me yesterday, when we had COVID, I could do the presentations at struggle online through Zoom, but I couldn't do anything with the practical. And the practical side of it's quite a big part of it, because you need to get a feel for it and understand what's going on. So I've started doing videos
And I set up 2 or 3 camera positions and cracked on with it. Talked my way through it, didn't script it, didn't really understand what I was doing. And went to then chop it up, put it together, and realised that the wind noise I hadn't put, because when I set up an iPad and an iPhone, I didn't realise how much the wind noise comes through the front of it. And I tried various AI routines to get rid of it, and it wasn't successful. And the stuff that I trialed that then you could pay for was not even that. And I thought, I'm not going to pay a fortune for something I'm not going to be happy with. Because what I found was it was taking away quite a lot of the dialogue. And yet the ones that they actually show you online using a GoPro or something, where there's loads of wind noise, and then they show you what it's like with the wind noise and what it's like after. I just wondered if they're manufactured, because I couldn't get it good. So what I did with some of them was put text underneath it. So it was like subtitles to show you what's going on. But they're all in my YouTube channel. But somebody was asking me yesterday, were they only in the YouTube channel? And they're not. They're in your Dropbox as well under videos. So if you want to have a look at anything, and it goes through the whole thing, how to type an offset, how to do triangulation or measure, how to do a check level, 2-peg test, how to take levels, how to take 3-hair stadia, how to use a proper instrument, how to use a spinning instrument, and then how do you compare them all to see how good the results are from each part of it. And the results were actually very good. So I was doing ellipses on where the errors were against the proper instrument, the 3-hair stacky, tape and offset, and chain and offset. Trilateration. And it was surprising how good they were. So you can achieve a good survey just with very, very simple things, as long as you approach it the correct way. And as I said, if you've got a garden, regardless of it, and you've got a face of the building, you've got front face there, side face there, it can even be the gutter line, it can be anything. And as long as you go down the garden, line that up so you're square on it, and you'll get better at that. Whacking a peg, the zeros on the corner of the building, you've got distance to there, that is your baseline, you can measure everything from that. And it becomes, you're breaking actually down to quite easy chunks. All these, which is how to go about surveying, what to survey, what equipment do you need, simple tasks, complex tasks, braced quadrilaterals. Now there's a nice one. A braced quadrilateral is you're measuring the 3 sides of it, well, 4 sides of it, then taking 2 diagonals. And once you've done that, if your dimensions are good, that is a fixed object. It can't be. And it'll only fail if one of your dimensions or one or more of the dimensions are wrong. And then it goes through with the leveling. What do you need? How do you do it? How do you measure height by basic methods? There's a bit on there about the height collimation method. And I was talking to somebody yesterday about the rise and fall method, which was another method we used to use a long time ago. And what the rise and fall method is, the principle of setting up the instrument, getting your horizontals fine. But when you take your levels, you're taking a level there, the next level, wherever it is, whatever it is relative to that on the difference in height, either up or down. And that's a rise or a fall. And you do that with all your levelings going through. So you're immediately finding out how land goes relative to the last level point. And you can still add up your backsides and foresides to make sure it closes. But the rise and fall method, when you reduce it, all you're doing is taking the value or adding the value to the previous one. And in the old days, before calculators, we found it much easier to do that mental arithmetic. Whereas if you've got height collimation method, you've got the height where the level is relative to the height of the staff and your datum that you're reading. That becomes your height of collimation. And every level after that, before the change point, is taken away from that height of collimation. So you've got to add on the datum against the staff reading, gives you height of collimation, and then you take everything. So when you get pages and pages of levels that you've seen from this one station, you've got to refer or keep it in your head, yeah, it's 11.5 minus that, and it can end up quite tedious. But it is, if you've got a calculator or a computer, it's much easier. And then you can apply corrections to that easier. Whereas the corrections and the rise and fall method, you would apply it to your change points. And let's say your change points wanted 2 or 3 millimeters addition to close out the level, because you did loads of leveling and you ended up 20 mil And 20 mil over 20 change points is only 1 mil per change point. And hopefully you're going to get compensating error, which you read it high one time and read it low the other time. One will compensate out the other. But if you end up with 20 mil, it could be just 1 or 2 bad heights. And it'd be crazy to spend a whole day re-leveling that to find out what your error was. What you do is you divide the 20 mil by the amount of change points you had, which was 20, and ends up 1 mil per change point. So your first one is 1 mil added to other levels. The next one's 2 mils added to the levels, 3 mils added to the level. So with height of collimation, it's easy. With the rise and fall method, because some of them are minus, so you take it on, add it on, all that. So the collimation way of doing things is much simpler, and that's what we're going to use today. But this tells you how to go about it. So you got advanced surveying, which is using the optical at the level as a theodolite, and that is using the circle to give you angles and using 3 Hz area to give you the distance. And then it's got areas and volumes. And then I've got examples of how to do it, contours, and then I've got the laser scan, which was talked to somebody earlier, the scan to go shows you what a scan data looks like, a point cloud it's known as. And if somebody says, we'll do that survey, we'll do it with a scanner and we can give you the point cloud once we've drawn it on, it makes a point cloud. Well, in there'll be some examples to show you what it looks like. And then I've got my videos, which were on the previous slide, showing you what they all are. So that is in there under revision 9 in your portal. And if you want to find out or can't remember how to do things, then you can go in there and look at it. And at the end of the course, I don't know if you guys still have access to the portal, whether it's all shut down from you. If it's shut down, then I would make copies of this. So you've got it to refer to in a year or 2 years' time. Good term, thank you. And if you need to get in touch with me to ask me any advice, how do I go about this? I can't remember what you said. Send me an email and I can find it. And if you want to get comparable survey, I'll get them to just give you a quote. And as I say, be quite clear of what you want. As I say, I've chatted and we did a few surveys then since I've sold the business and he's taken it on. He's a clever bloke. His presentation skills are very good, but he's not a surveyor. So he runs no, that's right. He runs a whole business because you get financial people. A financial person won't know how to be a surveyor. So I understand you laughing, but surveyors are not always the best businessmen. All right. And I used to treat the staff, I had 30 staff at one time, how I would want to be treated. So they all thought I was a great boss. But I was never going to make loads of money because we were never tough enough or hard enough. But I got on great with the clients because I told the clients what they were going to get, and I was honest enough whether I could do it or not do it. But you get people that are quite tough in business, quite hard, quite systematic and aggressive in lots of ways, and they do very well for themselves. Well, it was never about the money because surveying is almost a vacational type job. You do it because you enjoy it. It's not because you're going to make a lot of money. But it has always been undervalued because the PI, we used to have 5 million professional indemnity cover. What survey are you ever going to have that's worth 5 million? And I did 20 years for it. So we're undervalued, and when we go on site, the architects just think we're a bit of a plan. Because we get muddy wellies and a yellow jacket, they just think we're local because they never go on site and do that. You know, they're up there with their plans. But I've given some architects real headaches and got a serious sizable company removed from site because the work was rubbish. The bosses themselves and the guys that did the work were probably fine, but they didn't check it. So I was getting this drawing up St George's Hill, and they had arcs and different types of the building that I was going to set out. And you look at one drawing, it had an arc of whatever, and if you pick up another drawing, a different arc. So I didn't know what to set out because I've got to take that arc, bring that into my survey drawing, and then interrogate points around the arc at 20 mil, 200 mil, half a metre or a metre, whatever, to describe that arc. And then get the origin point, the one that related to anything else. With the bay windows and big curved areas and the patio on it. It was quite an intense job. Loads of money being on it. And I said to the client, I don't know what to set out, because if I set out the wrong bit, I'm going to get hung and drawn because they'll blame me. And they were getting pre-made windows and pre-made doors, and so if that design arc was say 12.5 meters in radius, right? But my drawings were giving me 11.5. There's going to be a mismatch at either end of it. What, 10, 20 mil? Well, regardless of what it was. So do I want to be responsible for £50,000 worth of glazing and that they said you got it wrong, you said it out wrong? So I went back, I don't know which one to use. Do I use the 12.5? Or do you use the 12.25 or whatever it was I worked out when I put, give me a centre point from these points, tell me what the centre is, tell me what the radius. And it was different to what they designed, basically. So well, I went to a big meeting, there was about 12 of them in the meeting. A client, these ground workers, these architects, not sure if there's any engineers there. And I came in with my yellow jacket and muddy welly boots, and they said, David, explain to these guys what's going on. So I said, well, I can't make head and tail which one's right. And I've done a lot of work trying to evaluate which one it is. And I'm scared I don't want to go for one, but they're bringing in concrete next week and I need to get on with it. So if I set out something, you're going to design that, then you're going to bring the windows and they're not going to fit. I said, you've talked a lot of rubbish. So I got on the phone to my partner at that time, Colin Harding. And this is the way when they started modems. And I said, can you modem the latest drawing? They split modem. I got from got the drawing up, showed them it, displayed it today. There's the two radius. I put points to that, tell the computer to give me the radius and the center point that was different. They're like, oh, blimey, what's going on here? So they must have got a junior or done something or revised it, but didn't update the drawings. But whatever happened, it was wrong. And they couldn't give them an answer to that. The client says, on your bike, and I think they lost quite a bit of money with it. I felt bad. But the thing was, I could have been stitched up and put out of business because it's obviously going to put it. And I had the same in a job in Woking with a block of flats, probably about 10, 15 stories high. And what they were doing is they built the structure, the concrete, and then they had brackets all the way along it that they were going to hang the brickwork on. So you had a gap of 100 mil, 150 mil. And when it went up the building, it was getting less and less or greater and greater, depending on which side of the building was. So they couldn't have the brackets going out more than 150 mil, I think. Otherwise, they lose the ability to support what's above it. And if they left it just on the brickwork, because these were effectively the brickwork ties, the brickwork would have bowed out and probably collapsed, and that would have been a horrendous problem. So they brought me in again to tell them what I'd found. I said, I can't set it out because it's wrong. Nothing is wrong. So whereas the edges of the concrete are not like you think they are. They're further away around. And again, I went to a meeting, there must have been 15 of them there, and I wandered in. Not in a very nice frame of mind, I can tell you. And I explained myself, and I said, it's not going to work because you got 50 mil there, 150 mil, 250 mil up there. You need to sort out some better brackets because the brackets are not going to sort. And I'm not the engineer, I'm just a surveyor, setting out the information for the brickings. Eventually they all said, yeah, fine. And I was on the brickwork company, this was for Barratt Homes. So they were talking about getting, if they were working on all the Barratt Homes sites, they'd probably get millions to do the brickwork. And I went down the car park in Woking, and these three big guys followed me down. And they were going to get stitched up by taking all the brickwork down and rebuild it and paying for all the new brackets and paying for my work. And because Barratt's just said, if you want to continue working for us, this is what you've got to do. And this, yeah, no problem. So these big three burly boats are going, I got into my car, I got off to my car, and I thought I was going to get duffed up. I really did. 3 of them come up because they're losing up a lot of money, serious amount of money. They come up and they said, David, what? No, they said, your explanation was great, we understood it great. If Barratt's don't pay you for the work that you've done, we're obviously going to pay them and they'll reciprocate that. Let us know and I'll give them some pressure. Thank you very much, you should have handled what I like. And I went, but that could have been really nasty. So you get situations where people do things wrong and you get around it. As I say, this last job at Lyndhurst Square could have been better, personally. But this was probably done 3 or 4 years old. I don't know what the date is on the drawing, but it's certainly, what is it, 2020?
2024,
Yeah, that's the
January 2024.
Yeah, it's the original one.
Where's the other one, mate?
There must be an original date. Anyway,
I don't have that to hand, sorry.
so I think, well, I'm sure they were using last year, maybe before that. So maybe it was end of 23, 24. Anyway, providing you tell them what you want. So you want contours at this interval, you want levels at this interval, you want all the gullies, you want any holes in the grounds, you want down pipes, you want windowsill, window heads, ventilation so you don't build something up against something that's going to cause problems within the house or outside it. So as long as you describe what you're going to want, they now know and they're getting better at the progress. And so because I'm giving them feedback, because I'm talking to you guys, and I've done a couple of surveys for them in the past anyway. And Cambridge Cottage, we could go close there and we could pull that apart, and I'm sure you would find something wrong. And if you didn't, I would find something wrong, because again, we're only human. But Cambridge Cottage has been all right. Certainly for the School of Horticulture, we've survived I inherited the survey of the sunken pond and the lily pond, where they are out there, and just in front of the school. And the survey that I got was 1:500 scale. Remember, you can't draw out less than 150. 1:500, and showed you levels every 15, 20 metres and edges apart and all that. So I slapped down the Orbit Survey digital data, which round here is quite good, apart from the shadow that they've got on this. And then decided that wasn't good enough to check what the guys were going to survey and draw up. So I took it on myself to resurvey it all. And because the company was quite busy, they didn't have any spare instruments. So I borrowed an instrument that had fallen over. It was all bashed, cracked glass. But I managed to use the software on it to get it to give me a result that I was happy with. So I surveyed it using that. The trouble was I didn't have I could put the pole up with a dummy assistant against the corners, but I couldn't code it all. Oh yeah.
Oh, we're confident foxes.
Yeah.
That's about it. No, they're in a good spot.
But anyway, so the laser, because it had been bounced, the laser was out 20 mil over about 20, 30 metres. So when I was shooting a corner or something, I had to make sure, think where the laser was pointing so I get the correct distance. And the survey's all right, and eventually found a handset to give me Bluetooth so I could check it all. Redid the survey. But every year, these guys are making plans at the same site, and I'm comparing them against my master. And every year, I find something that needs to be looked at. I had the floodlights twice the size as should have been was the first one. So where I'm punching it in the machine, instead of the diameter wanted for this feature, it must have used it as the radius, so it's really twice as big. And then there was a footpath edge that was, my line was, well, their line was in between, it's 50 mil out. And again, the drawing's at 1 to 100, so you're allowed 30 mil. So again, it's borderline. But I want to know who was right, either them or me. So I had to go out and resurvey it and check it. And obviously mine was much better than theirs. Well, it would be, because they've only had a week for me to teach them, then they've got to draw a professional drawing. But it makes me reevaluate it all the time. And the thing is, surveying is subjective. You know, if I take the corner of the wall up here with a laser and find it, depending how good the plasterer is, depends on what it's like further down. It could be a few mil out, but we're just talking about the differences, you know. And it's the same as the brickwork. If I take the top of the brickwork, it may well be different to the bottom of the brickwork, where it's been kicked and knocked about. And the laser will hit it or put it with the pole, and it was different. So it's subjective in that form. And you've got to then look at the plot scale, look at what the client wants, look at everything to find out, are you going to accept that? You're going to have to redo it. All right. So that is it. Any questions from anybody before we go outside? No. Right. So we get some warm clothes on. The rain looks as if it's kept off, so we'll do it. So we'll take the gear outside. We'll set up the levels. Show you how to do the 2 peg test out and check it. and then we'll just continue doing the bits for probably about another hour. All right? Okay?
Thank
Smash.
you, guys.
All right, Abby, and I'll see if I can video some of it. So you can see what we said. All right.
Thank you. Where did you say the videos were for your that you did in
They're in-
lockdown?
They're in the Dropbox and the videos.
Mhm.
If you can't find them there, if you go on YouTube, and he and David will be you find them in.
Okay, thanks.
Cheers.
Thank you.
Yeah.